All right, so it should be live. I've got, I'm going to be doing some live streaming of a telescope. So I'm using a technique called EAA, which is electronically assisted astronomy. It's essentially using a camera like an observational tool using some really neat software. So the technique uses live stacking. So we'll have a camera and a telescope, and it'll be taking many short exposures, and then software can combine those short exposures into an equivalent long exposure. So the longer we look at stuff, the more and more detail we should see. Just as a, right now this is actually live coming from the telescope. This has been stacking for about 20 minutes. Down here in the bottom left, there's some numbers. So we've stacked 153 frames for a total of 20 minutes, 30 seconds. And then up here toward the right, there's the exposure setting. And we're just taking short 8-second exposures, which means I can get away with using a really cheap mount because it's such a short exposure that the mount doesn't have to track super great. If it was a really long exposure, then any tiny, minute tracking error or motion in the mount would cause the stars to streak. So this is a kind of a general overview of what's sitting outside. So I've got a German equatorial mount, and it has 2 stepper motors on it that are being driven by this controller. And this controller is talking to a little mini PC that's sitting down here. So actually everything that we see on screen is happening inside this little mini PC, and I'm just remote desktoped into it. So I'm comfortable and warm inside at my desktop, but I can view and run this PC as if I'm sitting out there. So that's the mount, and then we've got the camera sitting in an 8-inch f4 Newtonian. So the camera has a really low read noise, which is, you can think of it kind of like the penalty for taking an exposure. So the smaller the penalty, the shorter the exposure needed to overwhelm that penalty. So having a really low read noise allows really short exposures, and it's coupled to a pretty fast telescope. This is an 8-inch f4, and the faster the telescope, or even if it were a camera lens, the faster the lens, the quicker you can accumulate signal. So again, the shorter the exposure you can use. So using a low read noise camera with a really fast optics, the effect is stacked. So you can use really short exposures with low read noise, and you can use even shorter exposures if you use that with a fast telescope. So that's how we're able to get away with really short 8-second exposures. And this software that we see here, this is SharpCap, and this is the one that does the sort of live stacking and accumulation. So with this program you can connect to the camera, and then you have this whole control panel over here. You can set all the settings for the camera, and it just continuously streams pictures straight from the camera. And we can actually view the individual pictures as they come from the camera. They won't be as pretty because it's, you know, instead of being a 20-minute long average or accumulating duration or integration, this is just a single 8-second exposure. And if we sort of enhance it and boost the brightness a bit, you can see it's very gritty and noisy, the individual frames. But the real sort of power and potential of live stacking is you can use these really short exposures, which make it really easy for the mount and the telescope to perform. But then you can use the software to combine it all to get an equivalently longer exposure. So you kind of get the best of both worlds. So if we go back to the live stack, you can see after accumulating frames for a couple of minutes, I had this running while I was setting up the stream. So this is 20 minutes is a little long for me. Usually I look at stuff for maybe 2 to 10 minutes, but even in a relatively short amount of time, stacking those short frames, you can start to pull out a lot of detail. So here we have 2 galaxies They're pretty small, faint ones. If I zoom all the way out, you can see they're pretty small in the field of view. But they'd be extremely difficult visually, but with the camera they kind of pop right out. And you can even see there's a little bit of color difference between the two. This one's kind of bluish and that one's a little more yellow. And these two galaxies are, what were they? NGC 7250 and NGC 7248. So this is a planetarium, which is like a digital map of the sky. And this is linked up to that computerized mount. So from this program, I can command the telescope to point at anything above the horizon. And if we zoom out, we can see where those two galaxies are in relation to all the other stars. So this is Cygnus is a pretty prominent constellation. There's Lyra, and then down here is Pegasus. So it looks like it's in the smaller constellation of Lacerta. I wish this particular program is carte de ciel. I wish I had a little more information on the objects. You can get a little preview by clicking on it, but it just gives you very basic info like brightness, size, and location. I always like at least having the distance or anything particularly peculiar about it or a little bit of its history. But this program doesn't have that. But you could always Google search it, or Wikipedia, or Simbad and Ned are good resources online too. So from here we can just sort of look around and see if anything in particular looks interesting. A lot of times I'll just kind of hop from one thing to another. Well, that looks pretty interesting. Let's check it out. I'm sure this has a sort of common name, but this program doesn't have that information, unfortunately. But if I were to search for the catalog number, you'd probably have a common name. So we're on target. I'm gonna type in the number here. IC5146. I'll make sure I'm actually in the text field this time. I forgot the number. 5146. So now we can clear the old live stack, and now it'll start to accumulate the new frames from the new location. So already in just that single first frame we can definitely tell that we're on target, and there's a kind of a diffuse red glow here, and it looks like maybe a murky kind of shadow. So seems to be a large dark nebula with a bright emission nebula in the center. So maybe one of these bright stars is lighting up the surrounding gas and dust sort of with enough energy to ionize it, and after it ionizes, it kind of glows like a neon sign So I think hydrogen in particular gives off that sort of reddish, pinkish glow. And you can see it's a little noisy. The background is sort of confetti-like, but the longer it accumulates frames, the smoother that background will get. I'm going to look up the object and see if I can get any information on it. It's called the Cocoon Nebula. I'm familiar with the name, but I'm not familiar enough to recognize it by sight. Says it's about 400 or 4,000 light years away. Which means that this is about 15 light years in diameter. And it looks like observations with the Spitzer and Chandra telescopes have shown hundreds of sort of young stellar objects, stars, in the process of forming that are kind of hidden in this murky darkness that the visual light telescope can't see through. And while this is building, I'll look for something nearby. Maybe we'll check out M39. It's not too far. It's an open cluster. So these sort of big giant clouds of gas and dust, eventually they kind of collapse into newborn stars. You know, the parts with a little higher density start to kind of collect and accumulate more dust, and eventually they ignite as stars. So in, I don't know, tens of thousands of years, I don't know the time scale, but eventually all this gas and dust will either be consumed into making new stars, or it'll be blown away by the newborn stars. And after that, you're left with sort of the skeleton of this cloud, just a bunch of stars all grouped together where this gas and dust used to be. But the stars are kind of related. They've are usually similar types of stars, similar ages, and they move through space sort of in similar velocities, kind of travel as a pack. And that's an open cluster. So we'll look at one of those next. See if we can boost the brightness of the nebula. It looks like there might be a little bit of reflection nebula in here too. So this sort of pink-red is from the ionized emission of excited gas, whereas this blue is just a plain normal reflection off of the dust. So this bright star is sort of casting enough light on the nearby dust that you can actually see a little bit of that light bouncing off. That's why it's sort of a cold blue. Oh, that's not good. Alright, I'm gonna have to troubleshoot this. I'll be back, let's see, hopefully within 5 minutes or so. Oops, I just realized I've been muted that whole time since I came back. I think my Wi-Fi dropped out, so it lost the connection for remote desktop. So we were looking at the Cocoon Nebula, which is a mixture of dark nebula and reflection nebula. And now we're looking at M39, which is an open cluster, which is kind of related. So that Cocoon Nebula is just a massive cloud of gas and dust, and it's starting to kind of collapse under gravity into individual newborn stars. And eventually it'll consume all that gas and dust, and any gas or dust that remains will get blown out of there by the stellar wind of the new stars. So after that point, you're left with just a really tight group of stars that are sort of associated with each other, similar compositions, similar ages, and they kind of move together throughout space. And that's called an open cluster, which is what we're looking at here. So the background is just jam-packed with stars because this is along the Milky Way. But you can see the really bright, prominent stars. There's sort of a loose grouping of them right here. And if I look up M39, we'll get some additional information on it. Says the distance is approximately 1,010 light years, with an estimated mass of 233 solar masses across all the members. And this down here that I've been playing with is called the histogram. So it's a very powerful tool, but essentially it's a representation of the kind of population of data, or how the sensor is receiving its information. So it's like a survey of how bright the pixels are. The more pixels at a certain brightness, you'll see the peak here. So over on this left side, that represents black, 0 photons collected, and all the way on the right is white, and enough photons collected to sort of fill the pixel. Any more photons, and you don't count them, they just overflow. And then in between is just a varying shades of gray, with sort of 50% gray being in the middle. And the neat thing is, instead of viewing the pictures as they come directly from the camera, sort of with the black point being at 0 and the white point being at 100% and the gray point being 50%, you can reassign it. So you can say, I want the new black point to be, all the way up here at 50%. And you'll see that the picture kind of becomes pretty black because we end up clipping most of the information. You can see the plot here. This is where most of the information we've collected is. So all sort of the star brightness, the background brightness, it's all here. So if we slide the black point all the way over here, then we're just throwing it away, we're cutting it out. But it can be really useful if you want to make the sky a little darker so that galaxies and other sort of very faint nebula stand out against it, you can sort of sneak up with the black point and try and darken the sky as much as possible. And then if you have a nebula that's sort of very faint, you can increase its relative brightness by remapping the gray point. So instead of gray being halfway between, or instead of like 50% gray being halfway between black and white, you can make 50% gray be much closer to black. And that'll really boost the dim nebula or galaxies. You can see we've got a satellite streak through here, that line. For an open cluster like this, it doesn't really have any nebulosity associated with it. Usually I don't push the gray point too much, because you kind of lose the subtlety in the stars when you do that. They all kind of get bleached out bright white, and sort of the brightness variance is lost. And this is all just preference and taste. You just kind of play around with the sliders until it looks however you want it to. I want to check out this little galaxy. It won't be a sort of massive, spectacular galaxy, but it looks like it has, in this little preview picture, it looks like it has some very nice spiral arms. Tonight the seeing is kind of turbulent, so I don't know how well we'll be able to resolve it, but we'll give it a shot. So this is a wide field camera that gives like a 40-degree field of view or so. It just helps reconnect with the remote mount out there because I can't really see the sky. So using this we can check to see if there's any clouds. It looks pretty good, pretty clear. There's I think a little bit of a tree there, hard to tell. But I'll get the catalog number for that. 7223. And I'll clear out the live. Oh, I forgot to save it. Oh well, it'll be there next year. So this is looking at an individual frame, and I can see a very dim, fuzzy spot there. So if we boost the histogram, that'll accentuate it a bit, and you can definitely see that there's something there. So I'll start live stacking. Oh no, I still have one more chance. Let me save this. And now we'll clear out M39 open cluster, and we'll look at this new galaxy, NGC 7223, and I'll look up some information on it and see if we can get at least a distance to it. It looks like there might be another galaxy not too far from it. And this is much sort of farther and fainter and smaller and dimmer, so it'll take a little while for the image to accumulate and to look anything like the preview. I think I found a distance for it at 213 million light years, which is around the time that Pangea, so the light that the camera is collecting was emitted from that galaxy 213 million years ago, approximately. So it means those photons are sort of came from around the time Pangea was splitting up. I think it was 250 million years. So shortly after Pangea split up, maybe, approximately, which is just insane. So those have been careening across the empty vacuum of space at the speed of light. So this will be a good example of the gray point. So I can definitely see something there, but we can accentuate it, make it a little brighter. I'm going to do something called dithering here. I'm going to pause the live stack. We'll look at the individual frames, and now I'm going to sort of manually command the telescope to shift its view just a little bit, and that will it'll help to smooth out the picture in case there's any sort of fixed pattern of noise on the sensor. If the telescope is tracking the sky fairly well and it's not sort of moving around, then that fixed pattern of noise will get baked into the picture. But if we shift the view a little bit, the fixed pattern moves with the camera and not the sky. And that way, as you start averaging slightly different perspectives together, that fixed pattern starts to average out. Ideally that you'd automate that and it would happen, you know, once every 3 or 5 pictures it would pause and shift, but I don't have that worked out. I'm starting to see some detail on it. We can compare it against this reference photo from the planetarium. Looks like there's a very dark, or a very small clump sort of off in this direction, and we can see that here. Whether or not that's just an intense star-forming region of a detached spiral arm, or if it's a dwarf galaxy or satellite, or if it's just something that's interacting with it, or it could even be just unrelated many million light years in the background. The view is a little bit blurry. It's hard to tell whether it's just the focus of the telescope is slightly off, or if it's the seeing, because the atmosphere kind of affects the view. It's almost like looking through a heat mirage on a hot day. It kind of roils and broils and sort of vibrates around. So instead of the stars landing exactly the same spot, they kind of dance around and in a long exposure that works out to just sort of smearing out bigger than it really is. So maybe I'll check on the focus eventually. Another way to check is if we pause the live stack, look at the individual frames, and then look at, say, this star here. Now we can just start decreasing the exposure time. Here's 1/8 of a second, and we'll just see how stable the star is. And it's definitely dancing around a little bit. So it's probably the seeing. We'll take that back to 8 seconds, and then resume the live stack, and then view the stack there's a setting down here where you can switch between looking at the raw frames coming from the camera or looking at the actual live stack. Now I muted myself again. All right, so I was pointing out we came here for this galaxy, but there's a bunch of other galaxies in this field of view. So you can see there's sort of smudges, little smudges here, another one there, a big one over here, and then up in this corner there was one, another one there, a couple more over here. Saying basically anywhere you point the telescope, and if you accumulate enough light for long enough, you'll see dozens of galaxies. There's a really fantastic Hubble picture where they set out to find sort of the most barren part of sky that had just absolutely nothing in it, sort of the least amount of interest, sort of bland blank area, and they had Hubble look at it for, I think it was a week or 2 weeks, and it just, the entire frame corner to corner was just full of galaxies. There was only like a handful of stars in the picture, so their field of view is way smaller than mine. Mine's just a tiny 8-inch telescope, and it's I think about a 1.4 degrees by 1 degree is my field of view. So like the Hubble field of view would just be a tiny postage stamp, but its resolution is phenomenal. So if you imagine exposing a picture of just this little region here with the Hubble telescope, it'd just be galaxies corner to corner. My little scope won't resolve those, but the brighter ones I can pick up. And a lot of these are cataloged too. So if you go in here and zoom in, you can see this is showing the ones that I had pointed out. So the small little smudges that are sort of down to the left and farther down from there. So these two, they're cataloged. And then even the pair up here was cataloged. Looks like there's a bit of dark nebula here. Let's see if I can accentuate that. Yeah, I definitely think so. And looking back at this galaxy, we can start to see a little more structure. So there's definitely one spiral arm here, and another one here, and then sort of a gap right there. And if we look back at the reference photo, you can see similar details in that. So I'll save a snapshot of this. And I'm kind of curious about this dark nebula right there, that cloud of gas and dust. And so this is in the foreground. All of the stars that we see, it's all within our Milky Way, our galaxy. And these galaxies are just way out there across the vast intergalactic space of just nothing. So all the stars are kind of, think of them as foreground objects, including this little dark nebula. I'm curious if it's cataloged here. Not showing up. Let's see this one. There's no preview image for it. So right now I'm just looking at the individual frames coming from the camera. I just want to take a quick look at this to see if there's any sort of noticeable form to it, any detail. Looks like an edge-on spiral galaxy. We'll just start live stack. This is the old live stack in memory, so we can clear it. Let's give this one a shot. NGC 7640. This one's probably prominent enough to have a sort of common name. I'll check for it. So I've just restarted the live stack on this new one. We'll let that build for a while. I think I've looked at this one in the past, and it's a pretty neat one. It's very irregular and kind of patchy and modeled, very low surface brightness, kind of challenging, but it gets pretty nice with more time spent on it. Yeah, no luck finding a name for it. But the Wikipedia article says they're not 100% sure if it's a spiral galaxy, just because it's very irregular, and they think that it may have interacted with another galaxy in the past. So it's been kind of highly distorted. Oh no, it says barred spiral here. Okay, so they say it is a barred spiral. It's just not immediately evident because it's so distorted from some past interaction. It says it's about 29 million light years away. There's another really nice galaxy not too far from this one. NGC 7331. Let's go check that one out. It has a lot more structure than this one. It's a little brighter. It also is pretty cool. It has it just happens to be in front of a bunch of background galaxies that are way out there. So let's clear out this one and we'll start stacking the new one. So the Wikipedia article says the main galaxy 7331 is about 40 million light years distant, and the ones in the background, these smaller smudges over here, they range from sort of 294 million to 348 million, which is about, I think that's about the time that Pangea was coming together, before it even broke up. So that's just insane to think about. The photons landing on the sensor are older than all the continents, as they, well, subcontinents of how they are now. Okay, I didn't get it in frame, but pretty close to this one, there's a really compact group of galaxies that are, I think, similar distance to these small faint ones, but it's a really tight group called the Dithering group. Okay, so it would be down here. If I had thought about it, I probably could have framed it to try and get both. So we can definitely see some structure in this one. You can see sort of it's a spiral galaxy, and we're sort of looking at it at a glancing angle. So all the gas and dust in the foreground is kind of silhouetted by the starlight, and then all the gas and dust in the background is lit up. So it has a very, very sort of 3D volumetric look to it. I'll just shift the telescope down to take a look at the Dithering group. So we'll clear this one out, and that'll start stacking on the new, which is really not too far away. Actually, you can see that's 7331, the one that we were just looking at, and these were just out of frame. So right now it's pretty gritty and noisy, just because we're only looking at 3 or 4 averaged frames, sort of less than 30 seconds of total data. But as we accumulate more and more, it'll start to smooth out and look less and less like confetti. And while this builds up, I'll look for another one, another target. And let's check for clouds too. Looks good. I know there's a lot of really small, faint, but interesting galaxies in Pegasus. I just don't know any of them by name or number. So with this program, I usually kind of hop around looking for previews just to see if there's any interesting structure there. This one seems pretty cool. Looks like a barred spiral galaxy. So it has a sort of central straight bar, and then the spiral arms come off the end of that. So I think after this one we'll check out some of the open clusters in Cassiopeia. I think it's just starting to cross over the Meridian. You see these little sort of dotted yellow circles, those are all open clusters. And the Milky Way sort of runs from right to left here. And then the Andromeda Galaxy will be coming over the Meridian, which is just fantastic. You can see this red square is the preview of the field of view of my camera. And it's just overflowing. It's huge. So the telescope will be looking at a sort of small chunk of it. It'll be extremely detailed. And then M33 is similar, another massive galaxy. Where they're, you know, just as big as any of these ones. It just happens to be a lot closer. I think Andromeda is only 2.5 million light years compared to these ones. Let's see what this one was. 7741. Let's see if I can get a distance for it. This one's about 40 million light years distant. And we can start to see the shape of it. We can tell that it's a barred spiral. It's got that sort of bright straight segment in the middle, and then it's a little faint, but some spiral arms coming off of it. And this has just been 2 minutes and 8 seconds of live stacking. The longer we'll stack, the smoother the background gets, and that helps the extremely faint sort of light from the galaxy stand out. Because right now it's the very, very faint feathered edge is kind of lost in the random noise. It looks like another galaxy right there. Sometimes they look similar to stars, but you can tell that the stars sort of have a sharp and abrupt transition. And the galaxies, a lot of times, they have a really bright core that sometimes can look like stars, but they're sort of smudges, they're extended objects, they kind of have a long feathered edge. So it looks like that one's a galaxy, and there might be another one there. And we can check the planetarium to confirm. So it looks like there's a bunch. Every little red circle is a background galaxy. And it's just this the biggest one here is the one that I noticed. So it looks like this smudge is a galaxy here, 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 another one there, another two here, another one there. It says there's one out here, but I don't see it. Maybe that one. But it's insane. Like anywhere you point the telescope, there's just dozens and dozens of galaxies, each one with billions of stars. And you know, if this is 40,000 light years or 40 million light years distant, and those other ones were 250 million light years, I can only imagine what these tiny, teeny tiny ones that barely register. I wonder how far those are. They get kind of hard to look up because they have sort of more obscure catalog numbers. You can't always Google or find information on it. I'll give it a shot. It doesn't look like they have much on it. Not a huge surprise. It looks like just with about 10 minutes of time, the spiral arms are a lot more defined. I wasn't able to find a distance for any of the teeny tiny smudges. It looks like they may have had redshift information, which I'm pretty sure you can calculate a very approximate distance from that, but I don't know the formula. I might try to look it up later. I'm gonna go check out some of the open clusters in Cassiopeia. They build a lot faster than the really dim galaxies. It looks like Andromeda Galaxy is starting to cross over the Meridian, which is this thick white line. So if we go to sort of feet on the ground, alt-azimuth view, and zoom way out, this is my horizon. I'm surrounded by trees, so it's pretty high up. And the North Star is right there, so I just barely have a view of it over my house. And the line that divides the sky in half from north to south is the Meridian. And right now my equatorial mount is sort of hanging out on this side of the sky, or the western side. So you can see the live update of the view as it moves over to the new target. So this is a really nice open cluster in Cassiopeia called Caroline's Rose. NGC 7789. Now we can start live stacking it. The clusters look pretty good in the single frames, but they also can improve a bit with stacking. It just makes the background a lot less noisy. And since it's a cluster and not a super faint galaxy, we don't really have to stretch the histogram so aggressively. And that way the star colors start to come out, which is kind of half the fun with the open clusters. A lot of times they're visually in the eyepiece, looking at them, even with a small telescope, they're really, really nice. And they tend to cut through light pollution too, which is nice. But you can see there's definitely some color variation in the stars. Yeah, we'll let that build. Makes me wonder what a night sky would look like from within a cluster like that. Just to have so many really, really bright stars so close. Save a snapshot. And for kicks, you can decrease the exposure time down to 2 seconds and just run around with the live view. Instead of live stacking, we can just watch the raw camera feed. And now when I use the motion controls, it should be fairly responsive and immediate to see the motion. And maybe we can even go down to 1 second. Bring it up to max gain. So this might be closer to the view in the eyepiece, more instantaneous, you know, except for the noise. So we can use this and hop around the open clusters around Cassiopeia. So here's one of the stars that make up Cassiopeia. You can see it looks like a big W. And with the Newtonian telescope, it has a secondary mirror that's supported by sort of metal strips. And having those strips in front of the telescope causes these diffraction spikes. So that's why the stars have the points. In a refractor, you don't get the diffraction spikes and the stars are just circles. And no matter how much you zoom into the star, it's always just an infinitely small point, because they're far enough away to be essentially infinitely small. But there are some crazy advanced techniques where they can actually measure the diameter of the stars and image them. I think with interferometry, using multiple telescopes with a large distance between them, you can effectively use them as one gigantic telescope, but it's sort of a compromise. It looks like two little open clusters here, really small ones. You can see the tight little group of stars. It looks like this one's sort of a little sparse, sort of loose with faint members, not very bright or concentrated or condensed like the other ones. Looked like there was a planetary nebula out here. Let me take a look at that one. Let's see. Although it looks pretty tiny. So it's only 94 arc seconds. So maybe 80 pixels for me in my camera. I'll give it a shot. I don't think this live view, not sure if it would show it. We'll probably have to switch over to sort of the longer 8-second exposures with live stacking to pull it out. I don't see anything jumping out, although it will be small. So I'm going to use a slightly longer exposure and a lower gain, and I'm going to select the dark frame to match. And then I want to live stack. We'll clear out the old one. And we'll see if we can detect it. So it looks like we've got, we're in the right field. So there's a bright sort of red-orange star, and then a kind of pale white one, another red-orange one, and then a yellowish one. And if we look in the picture, we've got the bright orange, kind of yellow, kind of pale blue, and another orange one. So we're definitely looking in the right spot. Now we can sort of compare back and forth between this catalog and the image. And this is very similar to how you find things visually with a telescope. It's called star hopping. So you try and find patterns in the sky, or the stars that you can see in the eyepiece, and compare them against patterns that you can see in the finder chart. So we've got this really bright star, and then there's a fairly bright one down here, which I'm not certain if I'm seeing it, so I'll have to look for another pattern to find. So we start here, there's a bright white one, and then a kind of chain of red ones, and that chain kind of swings down. So we'll see if we can find that. Starting here, there's the white one, and then a chain of red ones, and it swings down. So now that we kind of have a landmark to work from, we can compare the two and try and find this. So this is sort of like almost a right angle, and it's about halfway down the length of this, and then about half the length of that far. Probably doesn't make much sense, but if I could draw her on screen, it might. So I'm guessing it'd be somewhere about there. So we can just really boost the histogram. Might not look nice, but might be able to detect it, just barely. It's not confidently, but so I'm seeing an extremely faint semicircular centered on this kind of reddish star with a white one next to it. And if we zoom in to compare, I think that's the reddish star, and then the white one next to it. But that's extremely low surface brightness. I think this is where narrowband filtering would help. And time. The longer you look at it, the smoother the background gets, and the more faint detail you can pull out. This is probably the faintest thing that we've looked at all night. That would be a challenge. I can't even really see it. Andromeda should be crossing over. We could go and check that out. Just getting the using short exposures and stretching the raw camera feed just so we can see Andromeda come into frame, because it's just so awesome. So we'll pick it and then we'll issue the slew command. So you can see it's just enormous compared to the other galaxies that we were looking at. It actually extends way out of frame, sort of off in this diagonal and then off in that diagonal. And there's a companion galaxy, I think that's M110. And there should be another small one, M32? Yeah. But it's just out of frame for us. You should be able to use the mount control buttons to kind of pan around. Now we can see that other companion galaxy there. I'm happy with that framing, so I'm going to increase the exposure time back to 8 seconds, and we can start a live stack on this one. And even with the very short individual exposures, we could clearly see the dust lane, but once we start live stacking, it'll just be an incredible amount of detail will start to come out. So we'll clear out the old one. That Planetary nebula was kind of a bust. Couldn't really see it. And I think if we look at the M110 companion galaxy, you can even see a little tiny dark spot. It has a little clump of dust in there. Well, I say little, but an enormous clump of dust. And then with the gray point, or the mid-level here, we can really play around with it. You know, if we want to look at the sort of far outer reaches of the spiral arms. You can boost it, but we start to lose the core a bit. Or if you wanted to just look at the very core, you can slide it over. And we can just start to see some nebula within Andromeda. So I can only imagine how massive these nebula are that we can see them, from 2.5 million light years away. You can see some sort of patchy, bright blue spots of sort of intense star-forming regions along this arm here. And then tons and tons of just gas and dust. Visually, Andromeda can be kind of tricky to look at because it's so huge. A lot of times, a lot of telescopes have a kind of maximum field of view of about 1 degree, which is close to the vertical height of this field of view. So if you imagine looking at it with a circular eyepiece, it almost fills the entire field of view, and it's almost hard to tell that you're looking at it just because it has no framing, no dark sky around it to compare against. So a lot of times a small telescope is nice for trying to see the full extent of Andromeda, or binoculars are fantastic too. Any pair that you use in daytime should work for astronomy. In particular, 7 by 35, 8 by 42, and 10 by 50 are pretty good. If you're in a really, really dark sky, then a 7 by 50 can be beneficial, but if you're urban, then you can't really make use of it. Or I should say the 7 by 50s have a big 7mm exit pupil, so if you're in a really dark spot and your eyes can get really well adapted and your pupils open up to maximum, you can utilize all that extra light. But if you're in a sort of semi-urban environment and your pupils only go up to about 5mm exit pupil or entrance pupil, then the other smaller binoculars should work just fine with no difference. I might reposition the view and try and frame sort of each end of it. So we'll take a close look at sort of the far extent in this direction, and then we'll take another close look at the other end. But first I'm going to save a snapshot. I might save, I usually don't save the FITS file, which is just like the raw equivalent. I usually save a PNG, which shows exactly what's seen on screen, and it includes all the adjustments in the histogram and the color balancing. But if I save the raw files, I think I can combine it all into a panorama. So when I take the picture down here and the picture up there, I should be able to stitch it all together into one big long continuous one.
How are you feeling about the big show? Summer show? No.
Hey Sal, how's it going? I see you in Discord.
I'm doing good. How are you?
Pretty good.
This is nice.
Are you watching the YouTube stream?
Yeah, but I just came on now.
Okay. You might want to.
Yes, yes, I am on the YouTube stream too.
Okay. If you might want to mute the YouTube video, or else you'll start hearing like a big long delayed audio. You'll hear both of
Okay.
our. It gets really confusing sometimes.
All right.
But taking a look at M31, and I'm going to examine the sort of far reaches of it. Right now I'm looking right at the center of it, but I'm going to reposition and check out the edges of it. I'm getting a little bit of background audio on your end.
Yeah, hold on a second.
So this looks like a good framing. So I'm going to increase the exposure time back to 8 seconds, and then we can start live stacking. We'll clear out the old one. And I'm going to reset this sort of. It's possible to do 2 histogram stretches at once, and it can get really, really out of hand. So I was using the stretch over here to preview the individual frames, but now that I'm live stacking, I got to remember to turn that off and then just focus on the histogram down here. But we can already see some sort of, looks like blue star forming regions out in the fainter extent of Andromeda. And Andromeda continues on past this. You know, it probably goes on for another degree or half a degree. I think this one, this very bright sort of star cloud within Andromeda, has its own catalog number. Forget what it is. I think it's a 3-digit NGC number. No, not showing up here. There's actually a nice catalog of globular clusters within Andromeda. I don't have it for my planetarium, but it's something I've been meaning to get. So there's a lot of foreground stars that are within our Milky Way, but some of the sort of very small yellow faint star-like objects are actually globular clusters from M31, but without the catalog I can't tell which is which. I know some people observe them visually with large diameter telescopes. And I'll save this one and I'll reposition to look at the upper part of it, or the northern. So I'll exit the live stack, decrease down to 2 seconds, and then I'll boost the display histogram, and that'll let us see the galaxy, and then I can use the mount control panel down here and move. Basically, I want to take the bright center of the galaxy and put it down in this corner. So I could actually do it with this hand pad, or I could also try to do it with the planetarium program and tell it to position to the chart center wherever I drag it. And that'll probably end up being quicker than holding down the buttons. that's positioned where I want it. And now I'll go back to 8-second exposures, stop stretching the display, and then start live stacking. Then we'll clear out the old one and start accumulating frames from this new viewpoint. And we can see sort of the farther extent of the spiral arms. First picture is always pretty gritty, but as more start to average in, it cleans up. And you can always reduce the stretch on the histogram, and that way the noise isn't as violent. And then once it accumulates enough signal, you can start stretching more aggressively to highlight the fainter details. Can see a bunch of like either nebula or star forming regions kind of embedded in the gas and dust along that arm. I wonder what that is. Wonder if there's a star off screen or out of the field of view that might be glaring in, reflecting off of something. I think you might be able to take a peek at Mars. My telescope is not really set up for planetary imaging right now, so that Mars is going to be tiny, just a couple pixels, but be interested to see if we can see any kind of surface detail. To properly look at Mars, I think I need to use like a 5x Barlow, just because my Newtonian is a f4. It's really short focal length. which is great for sort of galaxies and stuff like this. Really funnels in the photons quickly, but for planets, focal length is needed. You can really see the modeling. There's bright patches and dark patches of, you know, newborn stars and just gas and dust obscuring. And a ton of detail on the dust lanes close into the center. I'll save this one. And I'll check out Mars. So this should be interesting. I've got it on 2-second exposures and auto stretched to show the sort of the live preview that we were using for Andromeda. And when the telescope slews over to Mars, you'll see just how ridiculously bright it is compared to these very dim deep sky objects that we've been looking at. Alright, so now that we're on Mars, we're going to want to use much shorter exposures. So we're at 1/2 second, 1/8 of a second, which is just still way too bright. And we can stop the stretching. And it'll get to a certain point where now we're down in, 4 milliseconds. And we can see that it's circular, but it's still completely overblown. We can keep getting shorter and shorter. Now at this point we can start to see the seeing, how it kind of dances and jiggles around. And right now the camera is downloading full frame, full resolution pictures, the entire 11 megapixel sensor, but we can use a region of interest so that it only reads a very small area around the planet, and that should allow us to get a much higher frame rate. So right now we're only getting 8 frames a second maybe. So we'll go over here. There you go, capture area. And we'll see if this is big enough. So this is a much smaller portion of the sensor, but we're getting much higher frame rate. Now we're at 70 frames per second. And if I use the telescope or the mount control buttons over here to make sure Mars is dead center, I should be able to pick an even smaller window and hopefully get a higher frame rate. So now we're at 153 frames per second. Now the proper way to sort of image planets is you'd essentially take a video of this and then run it through a bunch of software, and the software can pick out the best frames and then recombine them and sharpen it. But I can't really do that live on the fly. But I can try to live stack it. This isn't really the same thing as planetary stacking, but you can get kind of approximate. It'll at least take the jiggling and the sort of really shaking view out. So I've turned the alignment off because there's no stars for the program to align on. And now we're just gonna take a burst. And I think the seeing is probably going to be fighting us. Not seeing much as far as detail. But this isn't really the way that you're supposed to stack planets. And my my sampling is really coarse. You know, you can really see the pixels when you look at it. If I wanted to get if I wanted to focus on imaging Mars, I'd use a 5x Barlow, so the planet would be, you know, 5 times bigger. And if you're using an F10 Cassegrain, then you probably only need a 2x Barlow. But since I'm using a really fast Newtonian, I need a little more magnification or multiplication. It looks like there could be a dark spot. It just shimmers around so much it's hard to tell. Hi Tom, I see you in the YouTube chat. So I'm going to switch back to the full resolution of the sensor, and our frame rate's going to tank down to 16 FPS or so. Once the buffer gets full, it'll drop down even farther. And I just gotta go back and turn on the flat frame correction. Because when I changed the capture resolution, it sort of dumped the settings for the other one. So now I should be all set to go back to looking at deep sky objects. It looks like M33 is right on the Meridian. We could check that out. My telescope can go maybe 7 degrees beyond the Meridian, so we should be able to look at it as it crosses over. Hey Sal, I see you in the YouTube chat too. So I'm going to type M33 up here. Just so this gets added to the files when I save it. Not really a problem for something as recognizable as M33, but for, you know, those tiny, faint, obscure galaxies that we were looking at earlier, it's nice to have a catalog number to go along with them. So I'm going to use the controls down here just to center it up. So I've decreased it down to 2 seconds for a quicker refresh, and I've sort of boosted the histogram. Oop, that was a little bit too much. My mount does have some backlash, so I think what I'm going to have to do is purposely overshoot. And then when I reverse directions, there's going to be a big sort of lurching jump because I have backlash compensation turned on, but my backlash is not uniform across the gear, so I just have to kind of make compromise. So on some areas of the sky, my backlash compensation doesn't take up all the backlash, and on other parts of the sky it overcorrects and jolts like we saw. That should be good enough. We'll bring it up to 8 seconds. Stop the stretch down there. And then we'll start a live stack, clear out the Mars picture. And I'll remember to turn on the align frames. Otherwise, my mount's tracking is not very precise. So if this alignment setting was off, then each picture would just get stacked directly to the one previous. And as the mount drifts, the stars start smearing out and get, you know, streaks and blurs. But with SharpCap's live stacking, one of the best things about live stacking is the fact that it really is stacking. It looks at the stars in each picture and lines up each picture, and then it averages it, and that lets you get away with really, really sort of low-cost mounts that aren't, you know, super duper precise, but they're good enough for this. Like the equatorial mount that I'm using is a really old one, a Vixen Super Polaris that I got at a Stellafane flea market. So it's probably like 3rd or 4th owner with, you know, decades of life and use on the gears and bearings. And actually it doesn't even have a single ball bearing in it. It's all plain bearings, just machined surfaces with grease. And it works fine for live stacking because we can get away with such short exposures that it's very forgiving. So you've got M33 starting to build. I really love M33 because Andromeda is sort of, we're looking at it at a glancing angle, but M33 is almost completely perpendicular, face up. There comes a satellite blazing through. You can see little gaps in its track, and that's just the brief amount of time that it takes to read the picture from the camera before it starts a new exposure. So that the length of those little dashes, that's 8 seconds worth of motion, and then it reads for maybe a 1/4 second and then starts another 8-second exposure. It's a pretty bright one. I wonder if we'll see it on the wide field. Yeah, I don't see it. So SharpCap does have some more advanced settings where you can actually set up sigma clipping, where it starts to build average values for each pixel, and if any new value from a new picture deviates from the existing average by a user selected amount, so if any new value is too different from the old value, it ignores it. So you know, if this dark part of the sky, its average value would have been, you know, some dark value, but when the bright satellite goes over, instead of adding it to the stack, it would just ignore it and reject it. But I was talking about the face-on spiral nebula, like M33, you really get a fantastic view of the structure of it, and you can see the nebula within another galaxy, which is just phenomenal. I mean, I can only imagine how massive this bright nebula right there is. And I think these ones are bright enough to be cataloged on their own. So it looks like this one is NGC 604. Tom is saying the Super Polaris is a high-end mount in its day, and I absolutely believe it. I am extremely happy with mine, you know, for what I'm doing with it. So I think the mount was designed for a 13-pound payload, and I'm currently using it with a 22-pound telescope that's probably closer to 25 pounds with all the stuff on it, and then a 25-pound counterweight, and it just handles it like a champ. It tracks just fine, or at least fine enough for EAA. This live stacking, if we go to the drift graph here, this is a graph of how much SharpCap has had to move each picture to get it to match up with the previous one, and the numbers are in pixels. So it looks like I've got you know, almost 20 pixels of periodic error, which my sampling's like 1.2 arc second, so maybe 25, 26 arc second of periodic error, which isn't terrible. I've always wondered about this nebula there. You know, a lot of these are, you can see that they're pink, kind of hydrogen alpha emission, but then there are these massive blue-green nebula, which I assume is oxygen. Another one there. It looked a little bit sort of purple, so I increased the green color balance.
Hey Corey, can you hear me?
Yep.
Hey, it's Mark.
How's it going?
Hey, it's Mark.
You got a little bit of an echo.
Pinwheel Galaxy.
Got a little bit of an echo.
Not sure where that's coming from. Space, the final frontier. So I just was filming Pac-Man, and I don't know if you saw my picture in the email.
Oh yeah, with the jet flying by.
The jet flying by.
1 second.
Oh yeah,
with the.
If you 1 second.
Are you getting an echo now?
Nope. Sounds better.
Sounds better.
Oh,
Yeah.
now I am. I can hear myself.
I can hear myself.
That's pinwheel or fireworks?
Pinwheel.
Pinwheel.
That's what I thought, yeah, with a satellite. I wrote down notes that Glenn said that the object was 278, but I can't find NGC 278, so maybe I misread what the object of the month was. Thought it was 278, but
Yeah. What program are you using? And maybe it's not in the.
yeah, no,
Some truncate the catalogs.
Yeah, this one's just the Celestron program. Eventually, I'm going to use Stellarium or one of those, which is much better.
Oh, okay. Yeah. That could be it, because
Yeah,
some of the hand pads can only hold so much, so they have to sort of choose the best and brightest, where these challenge objects can be pretty faint and dim. We could try and go for that one next. Let me save a snapshot.
I'm sitting inside and I can still control my telescope. This is nice.
Nice.
This is good.
You're running with the USB cable to the camera? Or to the telescope?
Wi-Fi, but actually I might be wrong. Let's see, did it lose it? No, it's still getting the signal. Let's see if it'll connect. I'm pretty far away from it. Oh, my God, it connected. No, my goal right now, I was going to do Wi-Fi, but, and that will come. You still there?
Yep. I was just moving windows around.
Oh no, that's okay. That's okay. It gets really quiet, so I just. So the goal was to do Wi-Fi, but and I'm still probably gonna do that. But for now, since I have the Sony camera and I cannot afford to get the, I can't afford to get a designated Astro camera right now. And so I'll be using the Sony. I ordered a 75-foot long USB-C fiber cable that will come out of my Sony and go right into the computer. And I have full control. I'll have full control over the camera from the computer.
It seems like the Sony's been doing great. The pictures that you've posted for being a single exposure have been fantastic.
I know. I'm very impressed. I mean, you know, it's interesting because a question about cool cameras, are they literally cooling the chip, or is that an electronic cooling term?
They're literally cooling. So it's most of the benefit is for keeping the chip isothermal at the exact same temperature no matter what. Because the dark frames, they depend on the temperature of the chip. So if you take your dark frames at the beginning of the night and then it warms up as you take your pictures of your galaxies, when you calibrate those pictures of the galaxies at a warmer temperature and you're using dark frames taken at a colder temperature, there's a little bit of mismatch and that'll kind of print through a little bit. But if it was the perfect night and the temperature didn't change, there'd be no problem. Or if you had the cooled camera, it would maintain the temperature. So it's actually a PID loop going on inside the camera. It doesn't just apply cooling, it targets an exact temperature and it only cools the exact amount that it needs to maintain that specified temperature.
Okay.
But I didn't have a cooled camera when I started and it was fine. The little bit of difference that you get from taking your dark frames the night of, it's usually good enough. It's just sort of a luxury to have the cooled camera because it allows me to take all my dark frames. You know, the dark frames that I'm using tonight, I took maybe a month ago, and they're still good because I know the camera's at the exact same temperature. Previously, I would just take the dark frames when I was setting up, and it didn't really take a whole lot of time, especially because when you use short exposures, then the dark frames take less time to take. So it's not too big of a deal.
Actually, my camera's pretty cold right now because it's been out there for a couple hours, so.
Yeah, that'll help.
I mean, you know.
And
yeah.
the benefit of being cold is that I think it's the dark current or the thermal, I forget the terminology for it, but there's sort of an accumulating signal and the rate of accumulation depends on temperature. And for us in sort of Metro Boston area, the light pollution completely outweighs that accumulated thermal signal.
Yep.
So you know, if you spend all the money to get a cooled camera and run it to maximum cooling power to cool the chip down to reduce that little bit of thermal trickle, you've reduced the noise by, you know, less than 1%, because the majority of the sort of excessive signal is coming from the light pollution.
So I cannot believe this, but they do not have the Horsehead Nebula on this program. So
Is it B33, Bernard?
they don't even have it. They have got Orion Nebula, obviously, but when I go, I know it's near. It's near. I think it's Anatak. Star Anatak.
Alnitak? I'm terrible with names and pronunciations. But the eastmost belt star?
Yes. No. It's the. Oh, is it the belt? Yes, that is the easternmost belt star. Is that where it's near?
Yeah, it's just south of it. So if you're looking at the eastmost belt star, to the northeast of it, immediately northeast of it is the Bright Flame Nebula. It almost looks like a very dim version of the Trifid.
Okay.
And then south from there, there's a big, very dim sort of glowing wall of hydrogen alpha. And there's the dark silhouette of the Horsehead is on that wall to the south of it.
I think I'm gonna try for that later.
I'm hoping it'll come out from behind the trees for me. I'd like to see it tonight.
That's what I'm waiting for too. There's a big pine tree that I have to wait for it to come around.
Yeah, this is my horizon here.
Yeah, you have the French program.
Yep, this is a Carte du Ciel.
Yeah.
It's sort of clunky, but it's very configurable.
Well, so the way I'm going to do it now is I think what I'm going to try to do is I just ordered 50 feet of RJ11, which is phone cable, and I'm going to bring that out of, yeah, there was the veil. I'm going to bring that out of the hand controller, and I think I'm going to try to go direct, bring the hand controller into the house and run the cable, the USB out of the hand controller into the computer, so that I won't be dealing with Wi-Fi for now.
It might work.
I did get.
I don't know what the signals between the handpad and the mount are. If I assume they're not super high speed serial, so you might be able to extend it with the long wire.
I think I can. If not, I am going to extend the Wi-Fi, little Wi-Fi connector.
Oh, okay. Yeah, I see what you're saying.
There's the Celestron has this little Wi-Fi.
It plugs into the auxiliary port.
No, why is Delirium doing this? Technology's wonderful when it works.
So I'm starting to see some detail on the challenge object for NGC 278. Looks like
So
some spiral arms.
Find it.
Yep. I've got extensive catalogs installed in Carte du Ciel.
So how close is it to 1.4? I found 185 and 147, and I thought that they were supposed to. It was supposed to be close to that.
Looks like it. So here's 147, 185. then it looks like a
okay,
pair
so I
of
needed to
stars, and then
Yeah.
if you continue the same direction beyond the pair of stars, could be there. Or it would be halfway between Phi, Andromeda, and 185. So it'd be about halfway between.
Was it closer to Cassiopeia than I thought it was closer to Cassiopeia? Maybe I was wrong about that. Oh yeah, it is, but it's just further. Okay, so it's almost halfway between Andromeda and. I was close. Just didn't go quite. I guess that would be east. Okay, yeah, I see. I was close. Hey, I got the other two galaxies. That was pretty cool.
I think those were a challenge object maybe 2 years ago or a year and a half ago. Those ones are cool.
I'm a little late to the party. A little late to the party.
No, you got a challenge object.
This one's actually a head-on spiral, though.
Yeah, looks like it. So
Oh, by the way,
losing focus a little bit, or it could be the seeing. I'm not sure. I might check up on it.
actually, believe it or not, it's humid tonight. When I went out, there was actually, at least out here, I'm assuming because we're supposed to get rain tomorrow. I'll send you this link of this guy that I found online. It's a really actually, he's kind of boring. His voice, the guy, his name is, oh, that's you. You're not boring. Oh, David Butler. I highly recommend his videos on YouTube. It's just the name of his channel is David Butler. He does extensive videos on all of the objects that are in the sky.
Nice.
And he walks you through, like he has a whole thing on this galaxy that you're looking at, and he talks about all the different galaxies that are in the Virgo cluster, and it's David Butler. Like I said, he's not the most exciting speaker in the world, but images and the knowledge are really cool, and it kind of gives you a sense of place as to where you are when you're looking at all this stuff.
Yeah.
Is anybody else on?
It looks like there's people viewing, but no one in Discord. But you definitely see some structure to this one, sort of patches and models. Not sure if it's just the seeing smearing things out or if my focus has drifted. I don't have a motorized focuser on my system, so every now and then I go out there and retouch the focus with a bat knob.
That's so lame.
It's on the list, the project list.
Yeah, I know. I'm kidding. The fact that you're able to do what you do is amazing. So, yeah, I wish that I could control the Sony like this, but unfortunately, it's not. I'll have some control because the computer control, as opposed to the app control. Right now, I'm using the app to take pictures. But that's very limited on what I can do. Whereas the computer, if I take the camera directly into the computer, I have full control over the camera.
Nice.
I don't think there's any way to get that into Deep Sky Stacker or any of those programs. That's the only problem. I don't think they recognize that kind of. I mean, there might be a way to do it, but I don't think the programs actually recognize those cameras.
You might be able to find. So there's potentially two ways. It depends if it's on the list, but there was a ASCOM driver for DSLRs, with like the very popular DSLRs, and that would allow you to interface to astronomy programs for control. So like the side panel here, where I can select exposure time and gain or ISO, because you essentially connect the computer or the camera to the computer, and if that DSLR ASCOM driver works, then you can use the astronomy programs to directly address the camera or its ASCOM driver. The other option is SharpCap and some other programs have a folder monitor camera. So if you set up your Sony program to save its pictures to a specific folder, you can use a folder monitor camera, which acts like a virtual camera, and anytime a new picture lands in that folder, it appears in the program as if an astronomy camera took it.
So it's not quite live, but it's kind of.
It's pretty close to live. It's just instead of having the direct control panel here, it would be a separate program that's doing the commanding and saving of the pictures, and then SharpCap would just be picking them up as soon as they're laid down.
So you got is that dumbbell or?
This is the little dumbbell. So this is M76.
Okay, yeah, I saw that one. I started getting bubble, and it's funny, I got dumbbell the other night, but the trees were in the foreground. It was actually kind of a cool shot, because, you know, I'm sure that what I was seeing was just like the tip of a branch of a tree, but it looks like you've got trees in the foreground, so it kind of gives it some depth. Oh, very nice. They almost look exactly alike, don't they?
Yeah, pretty close.
Similar explosion.
Yeah, I think I might have to adjust my focus. I can see the diffraction spike here. You can see how there's like two parallel lines. As the Newtonian comes out of focus, the diffraction spikes start to do that. They kind of splay out.
Yeah, I noticed that in one of my shots tonight, so it's good to know now that I have a Newtonian. I am going to get the Coma corrector, but that's going to have to...
It can wait. Yeah. The center of the view is still pretty sharp without the Coma corrector.
Yeah, well, I did get the laser columnator, and that has been really helpful.
Yeah, it makes it so much easier.
Yeah, it does. I'm still a little rough on the secondary mirror, but pictures I was getting tonight seemed to be pretty sharp. So, and actually the outer edges seem. I think it's a better viewing night tonight than it was when I shot the other night.
I think I'm gonna do a Meridian flip over to I think Capella. I'm terrible with star names, but the brightest star in Auriga.
Don't hurt yourself doing that, okay?
I'll let the mount will take care of it. So
I'm gonna kill my mic, but I'll be on a little bit later.
Sure.
Always fun.
Yep. Good luck out there.
Thank you.
So right now I've just pointed the telescope at a bright star, and I've cropped down to a small region of interest so I can do higher frame rate. And I'm going to use the SharpCap focusing tool. So if we go to Tools, Focus Assistant, and Batten Off Mask. It won't work right now because it doesn't have the mask on, but what will happen is when I put the mask on there, it will analyze the spikes and find each spike's center and sort of compute a score. And then there's this sort of graph of scores, so you can figure out where your best focus is without having to like zoom way in on and use judgment on the shape of it. It works out pretty well. So I'm gonna go out there and do that. I'll have to hop off the stream for a while, or I'll just put a blank screen on there because it'll kill the remote desktop. So I'll be right back, maybe 5 minutes. Alright, I'm back. It was just a little bit off, not too bad. So I'll go back to full res. And I'll have to pick the right flat frame and dark frame again. So now we're on the other side of the Meridian. So I've got a whole new area to explore. And even after refocusing, you can tell the diffraction spikes are still not quite perfectly overlapping. And that's just my spider veins in my telescope aren't perfectly parallel and orthogonal because it's taken some damage in the past, and I've kind of bent them back into shape, and they're not perfectly in line. So even when I'm at perfect focus, I still have some splitting of the diffraction spike. But there are some pretty nice open clusters in Auriga. Take a look at them. Maybe we'll transition back to a sort of semi-live view. Oh, dang it. Alright, so I'm going to take it down to 2-second exposures, and I think I'll crank up the gain. I think that's a little too much. I was looking at the histogram here and seeing, you know, this sort of feathered trailing edge. If it doesn't end before the right side, and you get like a really big peak, usually that means you're clipping, and it's either too long of an exposure or too high of a gain. Alright, so this is sort of a pretty close to real-time view, a live refreshing frames. And we can check out some of the open clusters in Auriga. When I sort of shrink this page of Cartesiel, I lose the icon for the go-to command, so I think I'm going to add the icon right here just so I can have it. There we go. So now my slew button is down here. And that way when I make this window tiny and thin, I can still press the button I need. So this is another open cluster. This one's in Auriga, and it's near, there's a little asterism that I like. It's like a perfect little smiley face, especially in binoculars. It's a little too big to see in a telescope, at least any reasonably sized one. An 80mm refractor, you could maybe just about fit the whole thing. But there's two eyes and then a curved stream of stars that make a mouth. It's like a perfect little smiley face. And the way I usually find it is I go from, I think, Capella. I'm terrible with the names. But the brightest star in Auriga across to the far star. And if you make that move and go about 2/3 of the way, you'll be sort of land right on that smiley face. And M38 is sort of close to one of the eyes. And there's a nice NGC cluster down there. Let's see if we can get it in view. Yeah, you can see it there. It's a lot smaller with fewer members, but still nice. Might do a little live stack of this one.
Hey, that looks better. Focus looks better, I guess.
Yeah, I went out with the Batinov mask and it was just a teeny tiny bit off. I think a lot of it is the seeing.
Yeah, there is a little, like I said, it's a little humid tonight, believe it or not. Even though it looks pretty good, it's still got a bit of a humid humidity. The humidity's higher.
There's I really like,
Cluster?
this is M38. It's an open cluster in Auriga, and then there's a smaller NGC, what's the number? NGC 1907. I'm able to fit them in the same field of view. They're just two nice open clusters. There's a fantastic chain of open clusters that goes through Auriga and into Gemini, or sort of from Cassiopeia through Auriga into Gemini, all along the Milky Way.
One of the galaxies that this gentleman that I was telling you about talks about, I was looking at it. It's a, I wrote down the galaxy. Oh shoot. Anyway, because I think I'm going to contact that person, the woman who talked to us the other night, because in the shot of the galaxy, it's a Hubble shot, you can see streams going around the galaxy, and they're quite visible, of stars. Oh, look at that. Very cool. So I'm actually aimed at Orion right now. I have to go out. I'm making some hot tea first before I go back out.
It's a good plan.
I'm just going to pour it on top of me. I'm not going to drink it. I guess we're supposed to get super high winds tomorrow and Monday, so it's good that we get a little break here. And I might try for 278 before I go to bed, just to say that I got it.
Hopefully. It looked like it had a higher surface brightness than 185 or 147. So if you got those two, so you should definitely be able to get this one.
It looks like 185 is also a head-on, like a face-on as well, spiral. I could see some definition, obviously.
I think they're dwarf satellites of Andromeda. One of them has like a couple dark splotches, and then one of them's really sort of, they look a lot like elliptical galaxies.
185?
I forget which one's which. They're both sort of kind of look like elliptical, but one of them actually has a little bit of a detail in it, some dust. But one of them's almost completely devoid of. Why is this?
Structure. Yeah, I think 147, unless it's much further away. That's the thing. I don't know the distances that you're looking at as to how, are they big? Are they small like that because they're actually small, or are they small because they're very far away?
I think they're similar distance to Andromeda because they orbit Andromeda. I think they're satellites of Andromeda, but smaller, farther flung ones.
Then they're probably either irregulars or globular, so maybe I'm not seeing it.
I think they're dwarf.
Yeah, dwarf.
Sort of like our Magellanic clouds.
Yeah, I have a Celestron, one of the power boxes. It's got, it's pretty cool. I mean, they weren't that expensive, and that's what I normally run my telescope on, so I don't have to run power out to it, but I must have left it on because when I was slewing around, my scope sounded like, oh my God, what's going on with my scope? But it was just not getting enough power to run the scope, so. Now, what are you looking at there?
This is IC405. I think it's called the Flaming Star Nebula in Auriga.
Oh, yeah, I got that the other night.
It's a nice one with a blend of sort of blue reflection and red emission.
Yeah, I'm using the LHC filter on my camera tonight because since I was working with nebula, I figured I'd try that again. Yeah, I got this one the other night, obviously with the 8 inches. See, the other thing is you have the 294, or is it camera?
294.
And that's a 2/3 inch chip, or is it?
It's a 4/3, so a little smaller than APS-C.
Yeah, micro 4/3. So yeah, your field of view is smaller on that scope.
Yeah. With your full frame camera in the 6-inch f4, you must have a glorious, massive wide field to be able to see all the Milky Way stars.
Hang on, I gotta go get my tea. I'll be back.
Yep.
Yes, I recognize that. Mine was much smaller than that, but
How big are the pixels on the Sony? Do you know?
no, I don't. I could probably look that up.
Because it's possible it might have a similar sampling size, but just a much wider field of view. And you kind of get a win-win.
Yeah, the game is always figuring out. Like I said, I've been trying to keep my exposures to about a minute, depending on the ISO that I picked. Like when I was looking at Pac-Man tonight, you know, I was at 5,000 and I did a minute and I still wasn't getting. I think in post I'll be able to pull it out. That's the thing about shooting in RAW is that, you know, you have so much ability afterwards to. There's a lot more information in the picture than what you look at. Whereas you're basically doing the processing here live. But even with these, you could probably go into one of the post processes and get even a heck of a lot more.
Yeah, they so when SharpCap doing this live stack with the live processing, it's possible to save a FITS image of it, and that's already been calibrated, but it'll be like a 16-bit or a 32-bit FITS, and you can do some stuff with it. Or you can also just save all of the individual files too, and that way you'll have everything you need for a conventional approach with the dark frames ready and uncalibrated light frames and the flat frames, and then you can run the process however. But I usually barely have the drive to crop my pictures, let alone do a full astro process to them.
Well, it's been fun. I got a friend of mine from college, so I haven't seen him in probably 40 years, but we stayed in touch off and on over the years, and he's now become a mega astrophotography buff. He went out within the last 6 months, bought a Williams Optic 73, got a mount, professional mount. He bought my 224. I sold him that. And he bought my 120 for guiding. But he loves to post-process, so I basically put my files up on Dropbox. We have a Dropbox that we share. And so he's been doing a lot of the post-processing because he actually loves doing that. But
Nice.
You're getting a lot of the dark. You're getting a lot of the good dark stuff there too.
Yeah, it looks like I've got a dust mote that must have landed between when I took my flat frame and now, which is kind of funny. I've got like a dark donut right there.
Yeah, I had to buy I clean my own sensors now, which was scary at first because I had always sent it out to have it done. But I learned how to do it. Yeah, I see. The problem with mirrorless cameras is that, and I have to warn my friends about this, when you're changing lenses constantly, if you're not doing it carefully, it's very, very easy to get stuff on the sensor.
Yeah, it's just hanging out there.
Yeah, because there's really nothing protecting the sensor. So you have to be really careful. It's almost like collimating. You have to almost clean the sensor every time.
And don't they tend to have a static attraction too? Like to pull in dust if it's powered.
Yeah.
Sort of, but they also have an automatic cleaning mechanism, which usually runs every time you turn it off, because they'll shake the sensor to get things off of it.
Huh. Do they just like flip the polarity rapidly to fling stuff off, or?
No, it literally physically vibrates
Huh.
the chip.
I never knew that.
Yeah. You can feel it when it does it. Is that Chris?
Yep, I just joined. I was in another online thing, so I couldn't join you earlier.
How's it going?
It's going all right.
I'm actually tracking Orion right now, but I was freezing, so I'm not set up to be inside doing it like Corey is, so I have to go outside to actually image. Old school.
Mid school.
Yeah. Plus, I had some animal that came up. I couldn't identify it. I saw some fuzz, and it was breathing heavily. And by the time I got my light over, I could see something wandering off. It was either a possum or a raccoon. Then I have my headlight. I had that pointed into the woods, and there were some beady eyes looking back at me. So when you're this close to the marsh, the Ipswich River Marsh is right across the street from where I live. There's a plethora of animals that like to come and visit.
I bet you hear all sorts of noises at night. All the
It's
cries of foxes and marsh creatures.
Oh yeah, I hear my favorite are the owls. I love listening to the great horned owls talk to each other, especially on nights like tonight when it's very calm. But we have turkeys that fly up into the pine trees. And one night I was out there and I could hear dunk, 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 dunk. And I'm like, what in the world is that? They were pooping on my kayak.
Thunk.
I couldn't see it, but I kept hearing it. And the next day I went over there and there's frickin' turkey poops all over my kayak. And I was like, oh, that's what that was. I have since moved my kayak. I had 2 coyotes come up the driveway though once. That was kind of scary because they usually are pretty scared
Timid.
of us, but
To see brazen activity. This is
cluster is this?
M36.
Owl?
I'm not sure if it has a name, but there's a really nice chain of clusters from Auriga into Gemini. Even up through Perseus into Cassiopeia, just along the Milky Way there.
So yeah, I went after Pac-Man again tonight because I kind of like that one. I just think it's funny.
It is. It's a good one. It even has the eye. It's perfect.
If I stay up after Saturday Night Live, I might go out and see if I can get Bodhi again. I really like that.
My software claims that M36 is also known as the pinwheel cluster.
Oh, okay.
I suppose if you have a pinwheel galaxy, you need a pinwheel cluster too.
Yeah.
Well, we found the little dumbbell nebula earlier. Corey found that one earlier, which looks just like the big one except little.
Yeah.
I mean, it's amazing how the explosions look almost the same. It's I wonder how common that type of nova is. If it is a nova, it looks like it is.
Well, I guess it's probably based off of the initial size and spin of the star.
Or if it has a companion.
Hello, kitty cat.
Yeah. Yeah, I've got all kinds of animals here making noise. But yeah, no, so I mean, a certain size star spinning a certain way, should you would have a specific pattern, and then it would be a matter of if we're viewing it from the same side or not. As yeah.
Yeah, to see that plane's tail wing like that through a 6-inch scope
with the strobe perfectly sharp
was-
without motion because of the strobe
and
illumination.
You know it's the tail and not the main wings, because you can see where the main wings lights are. So that's why and it's also that it strobed right when it was going by a star. I thought that was kind of cool. Like I said, I've always, I've had planes fly through and you see the lights, but I've never seen one where you could physically see the plane.
Yeah. Me neither.
I don't know if you saw my email, Chris.
Yeah, I saw that earlier. Yeah.
Thought it was kind of cool. I mean, if you're gonna get photobombed by something like that, make it dramatic.
Be funny if you could get the tail number. Send it to him.
It's funny because normally I could probably track back and find out what plane it was, because I have all those apps. Flight Radar 24 is.
Oh yeah, true.
And I thought about, by the time I thought about, I'll go look it up and see what the plane was. It was long gone. So yeah, I thought, well, that's kind of cool.
It almost looks like a triangle, like sort of the densest part.
Yeah, but
it's like tri-lobed.
it's also amazing how many. It's also amazing how many of these named objects are named after some aspect of it, which you can only see visually because of how the eye works.
Yeah. You have to sometimes if I put the midpoint way off to the right, you can it gives at least a better representation of the relative brightness of the stars. It kind of squashes the dimmer ones to at least partially help.
I can see the pinwheel in that. I agree with you, Chris, that I'm sure the eye would see it slightly differently, but you can definitely see what they were thinking.
Yeah.
Yeah.
Especially like ET in the eyepiece, it's like so perfectly framed as sort of a figure with arms or wings. But in the camera, you kind of have to play with the settings to try to tone down the dimmer stars and bring up the major stars.
I want to know what Pac-Man was called before it was Pac-Man, because Pac-Man's only been around unless they only found that recently, which I can't believe that they would have.
It's the 7/8 pizza nebula.
Yeah, I really am looking at how limited this Celestron program is. I don't know if there's any.
Is it for the AVX? Is it? What type of mount?
It's for any of their. Well, basically, I have the Sky-Fi. I don't think it's Sky-Fi. That's Starry Night.
The wireless link, the Wi-Fi link.
It's Celestron's Wi-Fi unit, and so this app ties into that Wi-Fi unit. I haven't figured out if there's other apps that can recognize it.
If I remember correctly, Celestron software was derived from Sky Safari. So I think Sky Safari Pro could do it.
Ooh, I have that. Because I certainly would like to be able to use The Sky Safari Pro has a lot of stuff in it.
Hmm.
Oh, excellent. Thank you.
And if you end up trying to link it to a computer, you might see if they have an ASCOM driver, and then at that point you can connect it to almost anything.
Yeah, I think there are serial interfaces available for ASCOM, but I don't know about the Wi-Fi.
Yeah.
Well, what I'm trying to do, Corey and I were talking about this before you came on. Because I'm not going totally Wi-Fi right now, for a variety of reasons, I'm going to go hardwired. So I would like to be able to control my computer or my mount. I have an RG11 cable coming, which I would like to run it out of the mount to the hand controller, and then from the hand controller into the computer, which is what I can do inside. But I'm not sure, we're not sure whether the RG11 will carry the signal that far. It's about 50 feet.
That's close to that. Well, I believe the RJ11 is just carrying the RS-232 signals raw. I don't think there's a level shift. So an RS-232 cable uses high voltage to make the distance, so there's no special shielding
It's like
on a
plus
RS-232
12
cable.
minus 12 or something.
Yeah.
Well, okay, so
Although
if
this is between the hand pad and the mount. I don't know if they follow a true RS-232 protocol.
The hand pad has two jacks on it. The first one goes to the mount, and the second one is a serial port.
Well, actually, this one, the sky sensor or the star sensor mount hand controller that I have, I use the star sensor to align the scope. It's pretty good. It's not perfect, but it should be perfect, but it isn't. So that has an actual USB coming out of the hand controller. It's not a serial port.
Okay.
My older hand controller for the Celestron has a serial port. So I was hoping that if I do the RG11 to the hand controller and then serial port or USB into the computer, that but if you know more about the electronics, I'd love to hear it.
Well, in that case, so the issue isn't the RJ11 so much as what voltages they're using to talk to between the hand controller and the mount. And I haven't looked at that. I don't remember what that is off the top of my head. If they're using 12-volt UART, they're probably not using straight up RS-232, but they could be using just traditional single-ended serial signaling. Which, if they're using 12-volt, you'd be limited to the same kind of distances that an RS-232 cable would be. But if they're using lower voltages, then you're going to be out of luck. I think RS-232 cable you're looking at around, I think 50 feet is doable. It's on the brink.
But RS-232, is that the cable itself or
it's a communication protocol.
The connector is DE9, the 9-pin thing. You just happen to be running RS-232 over it traditionally.
See, because the hand controller is hooked into the mount, and the only connector I could find that fits into that is an RJ11.
Yeah, the physical. So the RJ11 is a physical standard, whereas RS-232 is a communication standard. I guess RS-232 specifies the voltages and things like that, and the timings. I believe RS230. If you're in RS232, with its voltages, I think 12 volts, you're looking at 50 feet is the specification.
So that's just about where I'm going to be. I think it might even be a little less than 50 feet. But the cable length itself is 50, so...
That's at 9600 baud. At higher baud rates, it would be worse.
Okay. Well, I'll find out next week when the cable shows up.
Yeah, so if they're using lower voltages like 5 volts on the hand controllers, between the hand controller and the mount, then it's going to be much worse.
Okay.
So I don't know what voltage they use. Maybe somebody has it written down.
I have to. Well, this is the problem when you know they should have this kind of information on Celestron's site, but they don't. You know, most of these. That's the thing about some of these.
You gotta see if someone's reverse engineered it in their own time. Pin out and check.
This is something that I've been talking to my friend about a lot of this software and stuff that should be no-brainer stuff. If I set my telescope up in the same place every night, pointed at Polaris, it should work. It should always go to the same place, but it doesn't. It's the most frustrating thing in astronomy.
So you have the same mount physically located in the same spot every time, or?
Yeah.
So how are you doing you're leaving it polar aligned, but then every time you boot it back up, it's coming up with a different alignment?
Well, currently I can do it both ways. Since it's a go-to mount, I can either use the 2 or 3 star alignment, which I did before I got the StarSense. The StarSense basically is a camera that does plate solving.
Yeah, I've used it on one of my parents' scopes. Yeah. And
it seems like it should work the same way every time, because as long as I set the mount up in exactly the same spot, which I do, it's basically going to the same spots in the sky to do its plate solving.
Sorry, I was too close to.
I like the effect. But it can be off by a degree. It's always close, but it's never.
So are you redoing the polar alignment every time with the polar scope, or what?
Well, no. What I do is I line up using the polar scope that's on the mount. You know, I literally physically line up. Is that Crab Nebula?
Yep, this is M1.
Yep, I love Crab. Yes, so yes, I do a physical polar align, even though the StarSense says you only have to point the telescope to the north, which I don't believe. So I get it polar aligned. So I'm always really close, but not ever right on. Sometimes it is, sometimes it isn't. Like the second time I did it tonight, actually the 4th time, it was like, oh, let's go find Mars. There's Mars. Wow.
I find that when you get to the more complicated alignments, the 2 and 3 stars, much more variance comes into play, especially if you have any kind of variation in the polar alignment. So you're not getting the exact offset correct on the polar scope, like that little ring with which hour mark the Polaris goes onto. Then things tend to be slightly more inaccurate or different every time you run the calibration.
So would it be better if I just point the mount to the north?
I don't think it'll be better. You'll have the same amount of difference every time you start it up. The most reliable thing I've found with my equatorial mount is if you there's a company which makes a camera. I think it's.
Is
I think it's
QHY.
the QHY one. Their
Polemaster.
star, the one that you put in place of your polar scope.
Yes, I have one of those for my Ioptron mini mount. My mini.
The SharpCap can do similar things too. You can
Yeah.
do,
So if you can usually just buy a different backplate for it, which will fit whatever mount you want. So you don't have to worry. Like you should just be able to buy a different backplate to put that on your AVX.
the polar line routine built into SharpCap is very similar, and you can use your imaging camera through your scope. So you point at 90 dec and then take a picture, hit plate solves, and then you rotate right ascension by 90 degrees, take another picture, and then it continually takes pictures, and you can do adjustments and watch the live feedback as that gives a visual representation of, like, it circles a star, gives you a vector, you just move the star until it reaches a target, and it also gives you a numerical left, right, up, down readout, and in like 5 minutes you can get within 10 arc seconds.
But yeah, if you whatever you use, if you get that spot on with one of these systems, then what you do is you just do a 1-star alignment with your scope.
Okay.
Because what that will do is, because you know that your polar axis is almost perfectly aligned, all you have to fix is the other variable of that it doesn't know about, which is your alignment on the across the RA axis.
Right. Well,
declination. So
your
1-star line will take care of that, and then once you do that, it's pretty much always the same every night.
Okay. The star sense actually does have it's funny because it does a plate solve on like 5 different locations, and then it says, well, you're deviating off of the polaris by this much. Do you want to do a polar align? And then it says find a star low in the north, find a star low in the south. That seemed to work. So it does have some of that capability.
Yeah, they all have that capability. It's just how much time you want to spend doing it.
Exactly.
These fairly wide field north facing polar alignment cameras, though, you can do it in just a couple minutes. And once you've done that, you don't have to worry about what the mount software is doing. The biggest problem I ever have is with the mount software, you can never tell what it's doing. They tell you, a process, but you don't really know what it's doing underneath the hood.
Right. You can't see the stars it's looking at. You can't, I kind of know what it's looking at because I look through the view of usually when I'm aligning, I keep the eyepiece on. I don't use the camera because I'm not connected to the camera. Once I can do that from the inside, I'll be able to do that. But so I always have the eyepiece on, and I can kind of look in and say, oh, okay, you're looking at those stars. You're looking at, and it's always the same stars. But you're right. It would be nice to be able to see what it's doing.
But yeah, you can use pretty much any camera if you're using like SharpCap. You just have to get it mounted to the polar axis somehow.
Well, you can just ride on the OTA. Like when I do my polar alignment, I'm shooting through my Newtonian with my 224 or 294. It's the same camera.
Yeah.
And because it's a longer focal length, the resolution is fantastic. Like when you're turning the knobs, you can really, it's not like the numbers are floating around and jumping around by a couple arc minute or a couple arc second. It's like pretty steady, and when you make little minor adjustments, it's reflected on screen, so it seems to read pretty accurately. Although one thing, you have to punch in your latitude, longitude, or at least latitude, and I think ideally temperature and altitude for refraction correction. It's like usually like an arc minute difference or so.
So who is that QHY that makes that? I think it is.
They make the camera and the software it's one of the easiest to use things I've seen for polar alignment. Their camera and software combination. If you already have the camera though, then you basically just need a different backplate.
Yeah, Pole Master.
Yep.
I gotta figure out how to get a video of doing the SharpCap alignment, because I can't really show it on stream running, but it's pretty straightforward.
Everything costs money, and I don't have any money right now, so
You can use SharpCap with your any camera you have on hand, even the Sony.
So that being said, I am officially selling my TPO 8-inch Ritchie Crichton. I'm going to probably post that in an email soon. Somebody almost bought it about a month ago, but I was too honest and told them, make sure that this is the scope that you actually want. And they did, and it wasn't the one they actually wanted, so I should have just kept my mouth shut.
No, I keep having people interested in the I keep having newbies interested in the 8-inch orange tube Celestron that we have. That's still on, but it's not a very good intro scope.
Yeah, it's relatively slow, right?
Well, yeah, it's SCT. It's F10, and it while normally I support manually driven scopes, an F10 manually a manual scope is a little daunting to find things with. The finder it comes with is very small, is not very helpful. And if you want it to track things, you plug it into your AC line power directly. You have to polar alignment, without a polar scope. It's just really challenging to use as a new newbie in astronomy.
Well, this one's not quite as. The only reason that I'm selling it, and that I think if I was doing a different type of astrophotography or this type of thing that Corey's doing, that I would keep it, because it's actually a really good scope, and it, but I really did want something that was faster, and I got the 6-inch because, well, it was $100 difference between that and the 8. Plus, as good as the 8 is, I didn't really want to lug the 8 around because it's a big scope, as Corey knows.
Yeah, it's about as big as you can easily sort of position and move with one hand, with right. a top bar. So like I have a 12-inch f4 sitting waiting for a mount, but whenever I end up mounting that thing, it'll be I'm shooting for a Dobsonian mount where I can just drop it into it. For a while I was considering an equatorial, but lifting that up over shoulder height into the saddle, holding it in the saddle with one hand to tighten the bolts when the thing's as bulky as a water heater and weighs 57 pounds.
Well, I will say that's where the Ritchie Crichton does, because it weighs about, I think it's 16 or 17 pounds, so it's not a super heavy scope, and it's for an 8-inch scope, it's the same, just a little bit smaller than my 6-inch. But the back focusing issue is a bit different. You have to add a lot of different, like if I go from an eyepiece to a camera, I have to add sections to do that, or take sections out.
Well, that's true of a lot of scopes.
Well, even the Newtonian, I have to, change. I have an extra section for my eyepiece that I don't need for the camera.
Yeah, the only thing I think of that doesn't need that are the Schmidt Cassegrains, because you can move the mirror a lot more.
But anyway, so if you know of anybody that's interested in that scope, let me know. I also have a Explore Scientific 102 doublet that I'm selling. They're both virtually new. Very good shape. I'm kind of starting over. I think a lot of us do this. I mean, you know, a lot of these hobbies, I found that I dove in a little bit too quick before I really got to. I thought that I had done all the homework that I needed to do, and I really hadn't.
No, I joined this club and I didn't buy a telescope for like a year and a half.
Yeah, that's probably a really good thing. I wish I had joined the club before.
So my first telescope I picked up was a 10-inch f5 Dob.
It's a great. That's what I started with too. For visual,
And,
it's
yeah,
hard to beat.
And it's an absolute workhorse.
I will say that I think having a Dob would. I have a 4-inch Dob that I bought from Astronomers Without Borders, which I'm actually going to donate to a school, or I almost donated it to the school of the town I went to see the eclipse in, because we got out to this park in the middle of their town, and the mayor of the town sent the electric company out to shut the lights off around the park, so that when the eclipse happened, the lights wouldn't block our view. And I was like, wow, I would never have thought about that. And sure enough, all the lights in the neighborhood came on, but none of the lights in the park did, because the electric company shut them off for us. So I was gonna, oh, what's that?
This is a pair of open clusters, and there's a smudge in one of them, and it looks like a background galaxy behind the cluster. And it's in... Oh, brain bending. There we go. It's... Where am I?
1807.
Orion, maybe? 1807 and 1817.
I was telling Corey that I found this great video series, if you're interested, on, if you're into galaxies, this guy's name is, hang on a second, where'd it go? I have too many windows. David Butler. And he does, they're kind of slow, but he basically takes you through superclusters, and it's just fascinating stuff. You get to see the Hubble pictures of all the stuff that we're looking at. So David Butler. All right, I'm going to go out and see whether Orion has risen over the pine tree, and I'm going to see if I can. I'll shoot the nebula first, and then I'm going to try to get the horse head tonight.
Nice.
Oh, good luck.
I'm hoping to see that tonight too, first of the year. But I've got a ways to go because it has to rise over all my trees.
I'm going to be up for a while because Saturday Night Live's on, so I'll be going back and forth between that and viewing. I watched the very first Saturday Night Live when it came on, and I've been a fan ever since, even the bad years. All right, I'll talk to you guys a little bit.
Yep.
If you're still
Later.
on. All right, bye.
Have a good one. The nice thing with plotting the horizon line in Cartesial is it gives you a local rise time.
Oh yeah,
so it
that's
looks
nice.
like I'll have to wait until 1:30 to get Horsehead.
Yeah.
But then again, these are soft, squishy trees, and I could probably sneak through if I really, really need to.
Yeah.
I saw the EV scope pictures that you had in Discord.
Yeah, it does okay. It's very easy to set up and use, but the amount of adjustment you can do to the images is a bit more limiting.
But having the turnkey ability is nice. I remember one night you said you had a meeting or something and you wouldn't be able to go out. But it looks like you were able to at least plop it down and get it doing its own thing.
Yeah, no, I set it up and just kind of put the phone next to my computer while I was in the meeting and was driving it.
Nice.
Then I shared one of the pictures to the meeting. Just clicked on the image, hit the share button, and then emailed it to myself. But yeah, no, it's the simplicity of getting it set up is, I think, the most attractive part, because really, you literally just walk outside, level the tripod, drop it into the tripod, and point it at a sky, and it's the focus isn't perfect until you actually point it at a star and focus it, but usually it's not too far off from where it was last time.
Nice. That's one thing I want to try to improve with mine, is to get it to try to automate more of the setup. Like if I do get the 12-inch going and get it on a Dob, not having to polar align would be pretty nice. And then to see if I can get like a plate solve routine where it can at least do some of its alignment. Try to emulate the EV scope as much as I can. Because I'd love to do this or do like the short exposure for outreach, but currently with the equatorial in my current routine, it takes me like 30 to 45 minutes to set up. And when they schedule outreach at sundown and there's twilight for like an hour and a half, and by the time it's dark enough to get up and running, the event's wrapped up almost.
Yeah. It's hard to polar align before it's dark too.
Yeah.
I do pick up a lot of gradient in my images though. That's I assume that's mainly just from the
Light pollution. That's a tough one to fight.
It really doesn't want to image right near the zenith too. It's funny. They're like, no, you don't want to image there, really.
We don't image at zenith. One does not simply image Alt-Az near zenith. Yeah, that'll be interesting. If I move to Alt-Az, I'll have to get acquainted with the limitations of it. Because even live stacking, if you're that close to zenith, the rotation rate is high enough, you get gimbal locked.
Yeah, the rotation's so high, and the likelihood that you're actually directly on target is also very. There's just so much error in your slews in that area. Mechanical error because of the gimbal lock, but yeah. It's an interesting color it's pulled out of that.
Yeah, this is Aldebaran.
Yeah.
Looks like I've got a little flare or reflection somewhere in there.
Yeah, I think some of that might be saturating one of the channels too.
I'll drop it down. It's
Still mostly yellowish.
Oh, I think I might know it. I'm looking at the live view, and I can't really color balance the live view.
Right.
So it usually has a really green cast, so that might do it.
Yeah.
But if I start a live stack, I can color balance in there. It's a bright one.
Yeah, it sends the colors all over the place. A little adjustment.
Oh, I like the rainbows and the diffraction spikes are cool.
Yeah.
It's neat to see the narrowband taken with newts, where it's just a bunch of dashes and dots from the pass bands of the filters.
Yeah. I hadn't thought about that. Yeah, that's interesting.
Is this open cluster lost? What's it doing out there?
So I looked a little bit at the hand controller question Mark was talking about, and it looks like they have some kind of proprietary one-wire protocol that they're using on that RJ11.
Is it just logic level 5 volts?
I think so. I've seen some people who claim that they've done extensions using a coax cable.
Huh. Just the shielding?
Yeah. I don't know. Interesting. Yeah, there's some people saying to be really careful with phone cables though, because sometimes they use a crossover instead of a straight cable, which could be a problem.
Have you been able to try the EV scope out at a darker sky?
No, I have not. I've only used it here in Arlington. The one time I got out to the clubhouse, I was purely using my Dob because I had missed using my Dob.
Yeah.
So.
Because the pictures are decent, like comparable to when I was using the 224 in the 4.5-inch f4, which is same sensor, same optics, and you know the integration times are longer, but from Arlington it's understandable. I'd be curious to see how it performs in a darker spot, just because it doesn't have to fight all that light pollution noise, but it's still doing a pretty good, valiant effort pulling it through.
Yeah, I have to drag the background slider way down to try to cut out some of the junk. Yeah, when they modified the software that runs on the phone most recently, they changed the two sliders. They're easier to use now, but a bit more limiting in what you can do. They basically now have it where you adjust the brightness and then the background. So I don't know how much of the
is like brightness equivalent to the midpoint.
Yeah, the brightness is equivalent to the midpoint, and then the background is equivalent to the other one. It's what it seems like. There might not be quite as much. Yeah.
But with some algorithm work in between. Who knows how they're doing it on the inside.
Yeah.
Can't tell if this is one really strange galaxy or a bunch of faint ones kind of smashed together.
Oh, interesting.
Looks like a ARP candidate. That doesn't look right.
You have your 2444 and 2445.
Mm-hmm.
That looks like two galaxies that are overlapping. Actually, maybe three.
It's a tough one. It's times like this where I wish I had the 12-inch working. Not that the seeing would permit much more. I really want to try and get the motorized focuser built and working.
Yeah.
Because the SharpCap has it'll talk to it, and it can run through a automated seek best focus routine where you just press it and it'll do exposures and step through the focus, and sort of you'll get a V plot where it passes through minimum and then it goes back to minimum and hunts it down. Which would be cool for getting it like automated setup. I think the next update to SharpCap, he's working on almost like a very basic visual programming language for doing sequencing. So you can have like sequences of blocks where you can, go to target this, expose for yada yada. But I think you could also sort of rig up a automated initialization where you could like achieve focus and then start the mounts alignment protocol and then plate solve, sync, and work it into the mount thing. That'd be really cool.
Now, I've seen some setups for that using some of the INDI K-star stuff, but I also have seen people using something similar they're using with what they're going to be putting on the new observatory, but they're using a full professional program suite to do that.
Yeah.
So yeah, there's two galaxies there that you're looking at. The big fuzzy at the bottom, yep, that's the 2444.
Yeah.
And then the one above that is the 2445. But there's one core there, and then there's a magnitude almost 15 star just above the core, which I think is the thing that you thought. Yeah, that's the 15 mag 15 star.
My view here is flipped, but I think this is the star and that's the core.
I think you're on the core now. I've got my software set up to match your view.
Oh, okay.
Picture of this.
Oh yeah, it's showing up as 3 galaxies. Or at least PCG. Is it
there's
2
a
different
PCG
cores?
there.
Is it 3 galaxies?
I think we've got 2 different groups of data overlapping now. It's hard to tell.
Yeah. So I think this one is double counted, and then this one is double counted. So the NGC numbers are duplicate, and then it's PCG and CGC. The Cartesial extended catalogs are really funky, where they're like weird blends of things instead of discrete individual catalogs. A mono camera would also help. I wish they weren't. The new 294 mono looks awesome, but it's also expensive. I had a lot of fun with the 290 when I was using the 4.5-inch f4 and the 224 sensor. I got
Yeah.
294 mono, which is about the same size. And that one was a lot of fun hunting for galaxies. Just because you get like a 3x bonus for sensitivity. You lose color, but galaxies are almost monochromatic anyway.
I'm gonna pull up Stellarium and see what it says.
It's got to be an ARP 143. It looks like a nice edge-on spiral next to it. NGC 2424.
Yeah, I'm still looking at NGC 2445 blob, and might be, yeah, there's a PGC in there somewhere, but it's hard to tell where one starts and the other one begins.
I guess it's a peculiar galaxy, ARP 143. in the subset of material emanating from elliptical galaxies.
Huh.
It might contain a ring galaxy, or in the process of forming a ring galaxy.
Neat.
So I think I've got the this edge-on galaxy here, and there's the bright star and the small star next to it. I've got that there, but I don't see whatever this is. It's not showing up.
Huh.
I wonder if it's... Oh, that's weird. NGC 2419, maybe? Wonder why that didn't show earlier. It's weird that it wouldn't show.
Yeah, I'm posting in Discord a link to that. Somebody imaged that NGC 2445. You can see the mess that that galaxy we're looking at is.
Jeez.
They call it a chaotic galaxy.
I'd say. I imagine what a Hubble image would look like. Just all the chaos in there. Jeez. Seven and a half hours on a 14-inch.
Yeah.
It's a really faint glob.
Yeah, it looks neat.
I imagine it'd be difficult visually with the sort of bright-ish star next to it, because it has a really, really low surface brightness.
Yeah, I wonder what that would look like.
So that was 2419.
2419.
Could be a good observer's challenge, or I don't know, it might be too dim. It says apparent magnitude of 9. The nickname of Intergalactic Wanderer. I've heard that before.
Yeah.
It says people with as small as 102 millimeters have seen it. It's one of the brightest and most massive globs. It's just really far.
It was the March 2011 Observers Challenge.
Huh. There'll be good notes in there.
It was named Intergalactic Wanderer because they thought at one time it orbited around the Milky Way, but it's now considered to be part of the Milky Way.
So its orbit carries it out beyond the Magellanic Clouds. But still primarily bound to the Milky Way.
Yeah. Very.
And some on the Wikipedia page it said someone had noted that it would be a best and brightest observable glob from Andromeda for anyone hunting for a Milky Way glob, because from their point of view it's not in front of us, so it's not obscured by our galaxy, so it'd be a choice one for trying to find.
Interesting.
I wish I had a good catalog of the Andromeda globs to hunt down with the camera, because it's really hard to tell them apart from stars. You need to have a reference. They just look like dim yellow stars.
Yeah, Roger made an observation with a 4-inch refractor in his report. He did a 10-inch and a 4-inch refractor. He's got sketches from both.
Nice. That's weird that it pops out in my catalog. Makes me wonder what else I'm missing due to lacking icons that only show up at maximum zoom.
Oh, yeah. That's kind of one of the hard parts of looking for objects to shoot on just using the catalogs, is how many things you just kind of gloss over.
Yeah. That's where at least Stellarium and Sky Safari definitely excel compared to Cartesiel. It doesn't really have a good weighted
even using
ranking.
them, I gloss over things sometimes.
Yeah.
The first challenge object was M1. Sure, why not? Yeah, I found myself going back to these observers challenge reports kind of frequently recently, being like talking about an object and being like, I wonder what that looked like visually when I don't have a if I haven't seen it yet. And then
Yeah.
they looked at it already.
There's a really great I can't remember the name. I'll be right back. There's a great book, The Night Sky Observer's Guide, from the publisher that recently closed, Wilman Bell. But it's
Right.
sort of similar to the observer's challenges, but it's just this massive collection of observer notes of, like, they do individual studies of entire constellations, and they'll break it down by, you know, variable stars and double stars and all the deep sky objects. And
Oh, nice.
they have breakdowns by size, so they rank all the observers' notes by instrument size, and they've got a couple sketches and pictures and stuff, but it's really handy. I should probably, let's see, I wonder if what was the 2419? And it was in links. Yeah, it's got a couple entries for it. The 8 to 10 inch, 12 to 14, and 16 to 18.
Okay.
Not nearly as you know, the entire summary for the object is maybe 4 or 5 paragraphs, including, you know, what it is, a bit of its history, and then what you can expect to see in different instruments. Not nearly as detailed as the Observer's Challenge reports usually.
Alright, I'm probably gonna drop off and deal with some things before bed.
All right. Thanks for stopping by.
Oh, that's good. Have a good night.
You too. Looks like a really, really faint planetary nebula in here. It's got a large angular size and a low surface brightness, so it might be tricky to pull it out from the light pollution. Let's check out this spiral galaxy, NGC 2403. We'll see how the seeing fares. Usually looking right over the top of a warm building is not the best. You can definitely see some nebula within that galaxy. This is NGC 2403.
Anybody still there?
Hey, how's it going?
Oh my God, my hands are like ice. Ah, Jesus. So I found Horsehead, but boy, is that dim.
Yeah, that one really benefits from stacking.
I was doing 1 minute exposures at 8,000 ISO and could just barely see it. There's another bigger nebula near it.
The
So
flame.
my question, which one is that?
I think it's the flame on the other side of the
Okay.
star, the brightest star near it.
Oh God, I'm letting my hands warm up. Sorry. I've got to find my cameraman gloves because I have a pair of gloves that have the fingertips, so I don't have to keep taking my.
Oh yeah, on and off.
Anyway, so I'm looking for. So I'm still trying to find 278, and I remember he said Cas Pi or Pi Cas, and I found that star. The problem is that I'm going to have to reconfigure my to use Stellarium or excuse me, Sky Safari Pro. I have to use a different. I have to reset the app for it because it's not recognizing the scope tonight. So I'm just using this.
Celestron.
But do you mind looking at your map again and just seeing what the stars are near it? Because if I can find those stars, then I think I can find it.
Sure. Let me get this stack going.
Okay. I remember he said Cas Pi was one of them, and I found that star, but I can't remember what the other stars were around it. Whew. Nothing like winter.
I remember when I first got my 10-inch f5 Dobsonian, I got it, I think, in January or November, I don't remember. But I remember using it out there in freezing cold and just the entire half of the tube being covered in frost from breathing on it. I had to bundle up.
Yeah, this will be a lot easier when I'm in the warmth of my house and I don't have to. I mean, you know, this is like the old school. Oh, what you got there?
Looks like a perturbed galaxy, and I think camelopard. If I can get the borders up, yeah. Camelopardalis, sort of not too far from the North Star.
When you get when you look for 27, I just need the stars next to it, but don't go away from where you're at now. The other question I have is it the man? What's the there's like 6 galaxies that are all in a row. Not Manchurian.
There's a Perseus A galaxy cluster. That might be it.
Yeah, it's called the chain. It's got a
Murox change.
Something like that, yeah. I don't know whether that's up or even in this part of the sky right now. Let me see if I can go to sky.
With the 6-inch f4 and full frame, why is there? That's weird. I'm missing all my galaxies.
Yeah, Horse said, boy, that's a lot tougher than I thought it was going to be. It's not a dark nebula. Well, it's a dark nebula.
Yeah,
but
it's a shadow. Or a obscuring, opaque.
Yeah, the actual nebula itself is very dim.
Yeah.
Okay, let's see.
Here it is. So if you were to get NGC 1275, that would be in a massive cluster of galaxies. And with the 6-inch f4 and a full frame camera, you'd probably be able to get, almost half of these in field. they wouldn't be like individually spectacular. They'd all be teeny tiny little yellow smudges, but there would just be, you know, the field of view would be full of them.
What is the name of the? What's a star there that I could find? What would be something that I could look
I think
for?
the brightest NGC member is 1275.
1275. Okay. I think I'll try for 278 and that, and call it a night. I found, okay, so 278, yeah, it's next to Cass Pi and Cass. And you're right, 147 and 185, they're all kind of in a line as well. But it's just out of the field of view of when I took the other two.
If you can find, so there's 147, 185,
85, yeah.
and then
Those, yeah,
these
it's Cass
two.
and Cass Pi.
Okay, yeah. So if you were to use these two stars
Yeah.
and then form an equilateral triangle,
Yeah.
you know, it wouldn't put you exactly on it, but it'd get you within the field of
Well,
view.
with this, yeah, with the 6-inch scope, I just need to, I see what I need to do. All right, I'm just going to let my hands warm up, and then I'm going to go back out and give it a try. 1275, I'll have to find where that is. Cass and Cass Pi. Yeah, you would think that,
You really see the red color in that dust lane.
you would think that Celestron would just use the same software, but no. Ah, Perseus A. Okay, good. So, oh, that's near Algol, which I was near earlier. That's a variable that Glenn was talking about the other night. Yeah, that's a cool galaxy.
It's a weird one.
Yeah. Yeah, that, like I said, that guy's videos, you get to look at these all in the Hubble catalog, and it's really kind of cool. Okay, yeah, so Perseus A, I see what you're, oh yeah, there's like a whole cluster of galaxies.
Dozens and dozens of them.
Yeah, cool. Oh yeah, look at that. Wow. Let's see if I could find that on the Celestron. I'm kind of okay, so that's very close to where I already am. Yeah, this is a lousy app. So I just go north of Algol and it's there. Okay. me back. I'll see if you're still here.
Yep. This one's pretty cool. It's also known as a monkey head nebula. If you look at it, it almost looks like an ape head with an eyebrow, the eyes, and then sort of nose and mouth. This next object's pretty neat. It's Hubble's Variable Nebula. It's not a particularly big or beautiful nebula, but it's one of the few nebulae that actually changes. So it's illuminated by a young star, and that young star is enshrouded in sort of gas and dust. And as that gas and dust flows in front, it basically casts a shadow on this wall of gas and dust. So it's almost like a puppet show. And in the course of weeks to months, it can actually change shape and brightness. So I had imaged this maybe 6 months ago. So I'm going to see if I can dig up my old picture of it while this live stacks. Then we can try and compare and see how it changed, if it changed over the time span. Alright, so I was able to find a old picture of it. I just gotta see when I took that. So this is from January 2020. I'm not seeing a ton of difference. Besides just color balance. I know back when I took this, I was not using a UV-IR filter. And tonight I am using a UV-IR, so there could be a very slight difference in there too. But as far as the structure and the lighting goes, they don't seem too different. So maybe I need a longer baseline. Although this one has a very slightly longer tail. There's a very thin, long, slender bit of light going down here. I don't quite see it on this one. Let's take a look at the rosette. I'm going to try and frame up the Bach globules. We'll start live stacking. Clear out the old one. I hope I remember to save that one. I'd like to have a sample just so I can compare in time. I can already start to see some of the sort of little dark filaments down here. I wonder if I'm getting a little frost or dew on my secondary again. I have like a little faint blue halo around that bright group of stars.
You still there?
Hey, how's it going?
Oh my god.
Cold?
Oh, yes. Oh, is that the rosette?
Yep.
Beautiful.
Yeah.
That's a
Really
that's
like
a
the
big
colors.
nebula.
It's huge. I'm
I mean,
only looking
it would
at a
fit.
part of it.
Sorry, I'm free. I just brought my scope in. I can't do it anymore.
I'm not looking forward to packing mine up, especially grabbing the counterweight, just a solid lump of steel at 20 degrees or whatever it is out there.
I think I saw you're using like a regular weight, right?
Yeah. Were you able to find the 278?
I found everything but.
Mm.
I searched all over that area, and it might be in one of my shots, but to be honest with you, I followed the line from the other two galaxies that I had taken pictures of earlier, and I thought, oh, okay, this will be it. That'll be easy to get. And nope, I found the stars, and was trying to do it the old-fashioned way and scanned around the area and looked and couldn't find it.
Hmm.
But I did find the Perseus A,
Nice.
which is cool. And then I went back over to Bodhi because I really like Bodhi.
Oh yeah, that should
And-
be right risen for me. I just
It was just over my house, same as it was the other night, and I was able to get both Bodhi and the other one that's next to a cigar galaxy, M81 and M82.
nice.
And there's another galaxy in the shot as well, and I'm going to have to identify it. I think it's one that might be north of, it was on the map, and so I have 3 galaxies in that shot, which is kind of cool.
Nice. It's like the horse head's just coming out of the tree for me.
Yeah, it's so tough with I thought it was going to be brighter than it was, but it really isn't. But it makes for a challenging target.
For sure, yeah.
Oh yeah, there it is. Yeah, that's the flaming nebula there. Is it south of that or north of it? Or
So my view is 180
upside.
degrees rotated, so
Yes.
it'll be south. So the flame is
Yes.
northwest of the bright star, and then the horse head south of it. I think I might have some frost or dew forming on my secondary.
I
Got
wouldn't
this
be
halo
surprised.
there.
Yeah, it's just starting to get to that dew point. Oh, there it is. Beautiful. See, now this is where I'd spin my camera because it's 16 by 9.
Yeah, it's taller than it is wide.
Look at, yeah, that's probably dew. Hence, that's why there's yet another thing to spend money on, the dew heater.
Yeah, I've been thinking of making one. You can get a little pulse width modulation thing from eBay for like $5, and then you have to come up with your own heating element, though.
Alright, so let's look and see what was the one next to Bodhi. Yeah, there's a boatload of galaxies in there. Oh my god. I'd like to see if it was Bodhi. It probably wasn't Bodhi Miller that found that galaxy. Skier. NGC3077 is in the bottom of the picture. So I got M82, M81, and NGC3077. Cool.
Nice.
Oh yeah, very nice. I'm just playing with it on my iPad right now. So what the you can do with the A7 is you can have it download the pictures right to your iPad as a JPEG.
Mm-hmm.
So then I can do a rough edit, you know, in that. So that's what I did when I sent that email out, just did a rough edit.
Nice. Makes it easy.
Yeah.
With this one, I have to offload it off of the computer that's out there running the mount, and then try and resize and crop it all with other programs. A lot of times I never end up doing that. So they just live somewhere as the PNGs that came out of this SharpCap.
Bodhi is a beautiful galaxy.
Yeah.
I'm getting my favorites, you know.
Mm-hmm.
Actually, the columnating's held from the. I didn't columnate tonight just because I was lazy. But I've been very careful about moving the scope.
Mm-hmm.
I think the 8s are supposed to be a little more sensitive.
Could be heavier components, more inertia, similar mountings. I usually collimate every time at the start.
Oh, I should too, but you know, I was lazy. I was gonna go out and look, and then if I had to, I'd bring it back in.
I think I missed the mark tonight. I've got the stars in my corner are elongated. They're kind of stretched a little bit.
Your focus is holding. Hey, there it is. Very cool. I think the whole Orion Nebula is, or the Orion, there's a ton of nebula in that.
Yeah.
Within
Bernard's Loop.
Yeah. Yeah, you're definitely getting some.
It looks like the Great Orion Nebula is clear of the tree.
Yeah, I did pretty well on that tonight.
This is my objective for the night, is to get the first peek at Orion.
Yeah, look at the size of that. I mean, that's all nebula around there, huh? Are you talking to other people as well?
Not really. It's whoever hops into Discord, and then I'll type into the YouTube chat whenever there's people messaging there. This should be bright enough to yeah. So these are 1 second exposures just rolling from the camera. So it's almost like a slow video. You can sort of surf around with the mount.
Oh, there's so much to see there. I mean,
Yeah.
I didn't realize that I had Running Man as well. the other night. You actually can get both of those if you panned that. If you pan it all the way to the right, you'll get Running Man in there as well. You have to
I'm gonna
go
try and
that. Yeah.
I want to try and frame more of the bowl. There's really faint filaments out this way. I think Running Man's somewhere down here. Because my view's flipped.
I think Running Man is to the
It's north of it.
Yes. Not very far north, though. So there's a lot of little galaxies around Bodhi as well. There's a lot of shit out there, huh? So yeah, in my Horsehead photo, I'm looking at it right now, I have both the flaming and Horsehead.
Nice. The flame has some good texture and it really looks 3D.
Looks like I have enough of the Horsehead to, oh wow, that's, I took one at a 208,000 ISO.
Mm-hmm.
It's super grainy, but you can see everything.
Nice. And with stacking, the graininess should decrease as you average more and more together, and the randomness of it starts to fade.
What I do with the that's one nice thing about the Sony is that I can pump it way up, and then that way I can do a short exposure just to find the object,
Mm-hmm.
because I can't kind of do what you're doing.
Yeah, that'd help to be
yeah,
able to get a preview before you commit to the longer 40-second exposures.
Right, and then what I do is I figure out, you know, I don't, the Perseus A I shot at 10,000 because I wanted to see as much of the dim galaxies as I could. That looks beautiful.
Orion is always impressive.
Oh, it's, yeah. Every time, I actually have my, I did a bunch tonight, so I'm hoping my pictures tonight are better. But, yeah, when I sent that to my friends, they're all like, oh, wow. You can't fail with that one.
Yeah.
off switch.
It's tricky to get the full dynamic range without blowing it out.
Yeah. The UHC filter helps with the colors quite a bit.
This is kind of like a faked HDR. So I started the live stack with short exposures that capture the inner details well. And now I've switched to longer exposures at higher gain to capture the faint kind of outer tendrils. It's an experiment. We'll see how it goes.
Yeah, the one thing you can't do on the iPad is you don't have a lot of control on color. So like I said, I just kind of use it to get started, just to see where I'm at. Then I can play with it. Beautiful, beautiful. By the way, Betelgeuse looked even dimmer tonight than it did the other night.
Looks like a couple interesting sort of dark nebula globs, but they're lit up and almost like little reflecting nebula, but they're shaped like little dark nebula globules.
Where are you looking?
I'm not sure if they'll show up yet, but I've just been framing it. And I'll start live stacking. But it's in Orion's belt. So there's the Flame and Horsehead. And then I'm between two of the belt stars right now. There's a satellite.
There's too much stuff out there to look at.
Yeah, a lifetime's worth. More than a lifetime's worth.
I mean, you know, that's why I've been trying to find some of the littler targets, just because it's just kind of cool to find them.
Yeah.
That's why that guy's video was kind of cool, because you know, you were able to see the Hubble images of what he was actually, you know, what you look at, and then you see, oh wow, that's a really big giant galaxy. Just looking at my drawing.
It's always so cool to like surf around with live stacking, find something small, obscure, and interesting, and as you're looking it up, if there's a Hubble picture of it, just to see the incredible detail that Hubble can get compared to like the little little tiny smudge that you're like, oh, that's a cool looking smudge. I wonder what it is, and then you find the Hubble picture and you're like, oh, oh my.
Right. So I did find 278. I see it here, and it's much smaller in a 6-inch scope than it is in your 8-inch. I definitely see it. It looks like a fuzzy star. Well, hey, I'm happy I found it.
You can definitely see the two clumps of dust, clumps of gas and dust.
Yeah.
It's funny to see them lit up like this, not sort of silhouetted against emission nebula or silhouetted against stars. They looks like they're just lit up from the really bright belt star. I mean, the haze from the dew doesn't really help. Gives it the soft focus effect.
Some of my clients pay a lot of money for that effect. Well, when I had clients. Somebody called me, they wanted me to do University of Connecticut basketball, and I'm like, the last thing I want to do right now is be around college kids.
Yeah.
I don't care how much testing you do.
In an enclosed court, too.
Yeah, absolutely. They said, oh, it's going to be at Mohegan Sun, they'll be doing testing, and I'm like, sorry, thanks, but no thanks. The vaccine is coming. Just got to be a little bit more patient. All right, let's see what my friend can do with this process. Upload these to...
There's a great series of videos from an ATMoB member called Nico Carver. His YouTube channel is Nebula Photos.
Yeah.
And he does really, really in-depth walkthroughs of stacking with DSS, with Deep Sky Stacker, like the full beginning to end process on, how to calibrate, how to apply the calibration frames within Deep Sky Stacker and all of that. But he's a really good YouTube channel. He does really good explanations.
Cool.
And it's not like a ton of fluff or no drama. It's just cold hard facts presented succinctly and well done.
How could I find that link?
I think if you're in YouTube and you search Nebula Photos, it might come up.
Okay. All right. The stacking program that I've been using now it's the Mac it's called Starry Sky Stacker. It's not bad. It gets you started, and then you take that into one of the other programs. So it's not a processing. It basically just stacks the photos for you, and then you can do a little bit of adjustment, but it's designed basically to set up the photos, and then you know, take it into Photoshop or one of the other.
This haze is getting out of hand.
Wow, my friend did a really nice job with just my stupid little iPad image that I sent him. Okay, so he also works in the same business that I'm in.
Mhm.
He's less of a shooter and more of an editor, and he actually works. He does the communication stuff for the Indianapolis Children's Museum. So
Nice.
he gets to do he gets to do all sorts of fun stuff. Kind of like the stuff I did when I was working on Zoom, but interesting. I got some of the veil as well. That looks pretty good. Yeah, it's out of focus.
Gonna do a live stack on Betelgeuse. See how crazy the haze will be.
Yeah, I think the humidity's starting to build in because, we're supposed to get rain tomorrow. But hey, it's been a good night. You can tell it's not crystal clear. I can always tell when I'm out here, where I can see the Milky Way, but it's still not defined. Because I've been out here, on really crisp nights where it's very well defined. Can you hear me dropping files, or is it just the microphone?
Just the microphone.
Oh, that's good. It'd be pretty obnoxious if you had to hear me putting files in my folder here.
I can hear a mouse click, but everyone can hear my mouse click, so it doesn't really matter. Well, I think I'm gonna wrap it up.
Okay.
Starting to get
Thank you very
loopy.
much. Yeah, I know. It. And you're inside.
Yeah.
Yeah, I'm still like my core is still warming up. All right. Well, listen. Thank you very much. It's always a
problem.
pleasure. And
It's always fun.
yeah, I'll put up if any of these look good. I'll put them up on the discuss.
Sure. Yeah, I look forward
Alright,
to seeing
thanks.
them.
Yeah, thanks, and thanks for your help as always.